Let's restart. Rewind. Thanks. Over to you, Alst. We're recording.
Thank you, Jim. So I'll restart. Good morning, good afternoon, and good evening, everyone. I have the honor to welcome you all to this Discovery Summit on behalf of ISIP. And I just wanted to say a few words around ISIP for those of you that's not familiar with us. So ISIP is a non-profit organization that's really focusing on service innovation. And I think this slide gives a good summary, because when I first joined ISIP, I was so delighted to find this unique platform that provides interaction between academia and industry. And I think this Discovery Summit is a perfect example of that, where we have really accomplished speakers, both from industry and academia. And the setting in this Discovery Summit for me is very unique, where we have short presentations, we have a panel discussion, and then we open up for interactivity with the audience, and really driving important topics or subjects for these kind of Discovery Summits. And we're doing this as a series, so the next one comes up in June. And if you have any questions or want to know more about that, please go to the ISIP website. If we look on the slide we see here, the goal of ISIP is to drive thought leadership and service innovation, and we really are involved in influencing the future of work and education. So we work both with the European Union and NSF in these really important questions. So again, welcome, and looking forward to the exciting presentations and discussions that's going to come out from this. So over to Yassi, our Executive Director.
Sorry, I was on mute. Thank you all. Good morning, everyone. Good morning, good afternoon, good evening, depending on where you are. Let me also add my welcome to all of you, and a special thanks to our distinguished speakers, without whom these Discovery Summits would not be possible. We really appreciate you sharing your knowledge and offering your point of view on important topics like AI and automation that are really enablers of service innovation. And as a small token of our appreciation, we offer Isip badges that acknowledge knowledge eminence. Also, a bit more about Isip. We also provide the opportunity for further recognition of our members through Isip Excellence in Service Innovation Award, which is an annual award. So I encourage you to check that out. And also, ISIP members have different forums, such as these Discovery Summits, but also progress meetings that happen twice a year. So, you know, it's we have different ways of getting involved. For those of you who are not members of ISIP, I invite you to go on isip.org and sign up. Individual membership in ISIP is complimentary, and it only takes a couple of minutes to sign up. So thanks again to the speakers. I also would like to thank Jim for putting this fantastic event together. And also I'd like to thank IBM for the sponsorship of this event. A quick reminder, please stay on mute. We are recording this session. And also, if you would like to ask questions, please put your questions, comments in the chat, as well as for those of you who are members of ISIP Slack, please add comments, questions, point of views there, and moderators will be checking all those channels. And also your point of views can be shared with Professor Ralph Badanelli, who's taking the lead in developing the white paper out of this session. Without further ado, I would like to introduce our first moderator, Rama Ikaraju. Rama needs no introduction to many of you. She's the IBM Fellow and CTO of AI Ops. She's also ISIP. She was ISIP president in 2018, and she's a member of the ISIP Strategy Council. So Rama, the floor is yours.
Thank you, Essie. I thought Jim and Ralph were going to say a few words as per the agenda. Is that not the case?
We are actually at the end. I should have rearranged the schedule, Rama, because we're going to do the closing. So we're good.
That's fine. Then let me go ahead and share my screen. Okay, share screen. Can you see my screen?
Yes.
Okay, all right. Welcome everybody once again, and thank you for being here. Several of you we have interacted before. I'm really looking forward to this panel session. Let me introduce a little bit about this panel. So there are two sections in this workshop today. The first one is going to be on business processes and what AI can do and how AI can help to automate business processes. And the second one is going to be on digital twins. Terry is going to be moderating that. So for the first one, here is how I was thinking about it. We have eminent experts in the area of business process management joining us here today in the panel. We're going to be discussing how AI can drive automation. Just to kind of set the context for what we have asked the panelists to speak about, let me say a couple of words. We all know that AI is increasingly being used in enterprise business processes and business process management. And that includes anywhere from, process automation assisted by virtual assistants, say in customer care domain, in healthcare domain, legal research, social media monitoring, in financial services, in IT operations management, security, contract understanding. Many different areas are in business processes are being touched by AI, whether it is for automation or decision support, optimization, recommendations, or whatnot. As we do this, and as we see more and more of business processes and enterprises embracing AI to drive this automation, as part of this panel, we want to be able to discuss what are some of the opportunities that AI presents and what are some of the things that one should watch out for in the journey to AI-powered automation. So I want to touch upon these two things briefly. Many opportunities exist with AI in business process automation. They range anywhere from automation, as in the case of autonomous vehicles, self-managing IT systems, or AI-powered optimization, such as robot or vehicle trajectory planning or automatic travel reservation systems, which require optimization with some kind of constraints, or decision support, like in the case of IT incidents that occur and that need resolutions. Augmenting human intelligence could be a use case and an opportunity. An example of that would be IT anomaly detection in IT systems. Systems automatically doing that and in that way extending human capacity. Personalization, as in natural interactions that humans will have with computer systems, being compassionate, understanding their preferences and carrying out compassionate interactions. And natural interfaces, interactive voice agents in cars and customer support. So when we say AI and automation really is a spectrum of things. It's not just one modality. It is automation, it's optimization, it's decision support, it's augmenting human intelligence, it's personalization, it's interactions through natural interfaces. We mean all of these things. And when we talk about how does one go from wherever they are to really leveraging AI for automating business processes, there is a journey. And we can see that we're already making our way in that journey. There is process analysis we can think of as how we were doing it, say we'll call it 1.0, Two, where we want to head to and where we can get to, say, call it process analysis 2.0. And that could be, how we were dealing with structured data only primarily for analyzing processes, to dealing with both structured and unstructured data. From being very reactive and making predictions and stopping there and letting users figure out what to make out of those predictions and what actions to take, to being proactive and providing actionable insights and automatically executing, those actionable insights where possible. From pre-built dashboards to interactive natural interfaces, passive decision support to proactively AI leading automations, and discrete human-led optimizations to natural, more human and AI symbiotic optimizations. All of these are possible with AI, and it's going to be a journey, but we are at an interesting point in time where we have enough of the technologies and advancements in compute and in the algorithms, both on machine learning side in general and AI side, to really enables us to go from this 1.0 to 2.0 now. So as we go through this, different eminent experts in the field are going to be sharing their points of view. Towards the end or during their presentations, I hope they'll touch upon these points. If not, we'll discuss these as part of the discussion. So some of the panel questions would be, what are the use cases that are amenable for automation in business processes? And we'll go into the details. Are there specific attributes and properties that make certain business processes more amenable versus certain others? Do we have proper bridges built that show that the process automations or optimizations being proposed actually improve the business metrics and show value? And what are we doing as a community to build those bridges? Has the time for automatic process orchestration come? There is a lot of discussion. And in fact, just as part of the Think conference this week, IBM has announced Watson Orchestrate. So I would love to hear panelists' opinion on the opportunities in orchestration. How real is automatic process analysis as a means for continuously improving processes? Are we there yet? I have some specific probing questions we'll discuss during the discussion time. What tools, platforms, and skills are needed to put AI to successful use in business processes? And finally, what are some of the best practices for successfully transforming and optimizing business processes with AI? So these are some of the motivating questions that led us to have put this panel together. With that, I will invite our first speaker in the panel, Jerry Kumo, IBM Fellow, VP, and CTO for IBM's Automation Business Unit. Jerry, looking forward to hearing from you. Over to you.
Oh, thanks, my good friend, Rama. Let's see, let me share my screen here. Assuming you all can see this. So let me start by just saying good day, everyone. I'm Jerry Cuomo, and I'm pleased to talk about a point of view on AI-powered automation. Let's dive right into it. So a definition of AI-powered automation to start. And I'll start. I think we all know this and drive inspiration from this, but automation is not new. It's been around since as long as there are people. We kind of have evolved to use tools to make our lives simpler and easier. And I think automation is at the core of that. In fact, early patents are amusing to read from the early industrial era on steam engine automation, regulating speed with kind of data-driven closed feedback loops, right? And you can fast forward to a few weeks ago when I test drove a Model 3 to really see this process of automation. So it's important to continue to see what in history what works and build off of that. So this process is tried and true and omnipresent when that Tesla Model 3, magically changes lanes or slows down, right? So it takes that automated action. So how did this happen? It's this process, and you can call it, you can use descriptors in many different ways. But over here, I'm calling out a discovery phase. Again, it's a data-driven process. So this is really about mining the data. In this case, radar data coming from north, south, east, and west, and everything in between of the car. And then as we're discovering, we're driving some automated decisions, is the car in front too close? And then, driving some actions perhaps on a threshold that gets exceeded, a probability that, yes, indeed, that car is too close, steer to the right, the magic happens, right? So really, when you sit back and think about it, cars have become computers. And the software that runs on these cars do amazing things. But the quintessential thing is around autonomous driving. And it makes you think about businesses today, especially post-pandemic, or I like to say post-pandemic, where not everyone is quite out of it yet. But it's really forced companies, businesses, to be computers. The best companies out there, ordering a pizza, healthcare, telemedicine, our Zoom-enabled workplaces, all digital, right? So this, is the equivalent now of the car becoming a computer. The enterprise has become programmable like a computer. It's ripe for automation. So it makes us muse about applying this process to business to make a self-driving business, or at least an auto assist. I think automation and AI is best when it's human in the loop working together, right? And I think to start the definition, we draw inspiration from that. And if we look across, IBM has really adopted this automation dial as the definition of AI-powered automation, but also kind of how we're organizing our thoughts about how to bring AI to bear over the space of automation, and clearly across this discover, decide, act, and optimize process. And I think what we see, and I'll mention it again, is automation works just fine, and it's worked fine for years. I think where it gets tripped up a little bit, and certainly where AI helps, is where things become a little noisier in a business process, more ad hoc. I guess noise would occur to unpredictability, maybe data that is less structured. And that's when humans are required in the loop. And when that happens, things, automation slows down. So we believe we can apply automation across this dial and really improve and increase the scope of where automation could be applied in an enterprise. And it really comes down to this two-step dance of eliminating repetitive mundane work. So using this technology across the dial to eliminate those repetitive actions, but not just stop there. So automation is not just about cost reduction and eliminating human activities, but it's really about making us all superhuman workers by enhancing and augmenting our skills so we can see things, respond to things very effectively. Heck, you'll see in an example even before they happen. And that's certainly augmenting skills in a big way. So resilient delivery is part of the result with speed, lower cost, and improved experience. Right? So I think that's kind of at the tip of a definition. But someone might say, "Oh, that's awfully vague, Jerry. Can you bring it home? Give me an example," especially at this ISSIP conference around service innovation. Where is the opportunity to innovate from a services perspective? So from a banking process, let's pick one. It's one of our bigger industries that we serve in IBM. Let's just take a quick look. We've identified these banking processes as prime target for business automation. And in summary, what can be automated in a bank?
I'll have a little taste.
Answer everything and anything, just about. And we're also trying to tie it from a services perspective to help understand what types of savings are involved. Let me just really run through a quick example around customer service. And this is a real example, and it's in the backdrop of COVID, where a big global bank is seeing an increase in email interactions from their clientele, right? So folks want to interact digitally with the bank, don't want to necessarily go into the brick and mortar banks. They're making requests requests, asking questions about bank products, and of course, filing complaints. And now the bank is faced with a significant influx of communication from their beloved customers with information and data embedded in an unstructured way in these emails. And they're finding themselves putting a lot of time and money into processing this. But even with that, they cannot meet the demand and response times that customers expect. So customers are getting frustrated. Their net promoter scores are going down. What do? AI-powered automation. Why not? So the bank looked at putting together a set of classifier models, specifically an intelligent document processing pipeline to capture, classify, and extract relevant information from those emails. And as I mentioned, this classifier model was specifically trained around bank products and bank personnel, departments, and methodology to take that unstructured email and to automate the receipt, the categorization, and response, right? Net result, beautiful, 90% reduction in handling times, 94% more accurate. But again, that's just step one. That's the cost savings part. The real value is on customer service. It's around service innovation, because now what they can do as superhumans with some sentiment analysis on these emails is understand that one of these emails, and this is about targeted response, one of these emails could likely be from a relative that's closing a bank account due to a relative that died from COVID. Now's the chance for the bank to earn their stripes with compassionate, as Rama said, compassionate customer service, providing it at the right time in a meaningful way to drive a great service experience at the bank, right? So it's that two-step dance of reducing and eliminating mundane work such that you can augment human skills to do amazing things, right? So a simple example, but an example at that. All right, so my remaining time is I'm going to quickly go through the various phases here of discover, decide, and act. Again, optimize is happening continually, you'll see. And call out places where AI-powered automation can make a difference and is making difference in how we work with and innovate as we service our customers. The first is around discovery. And as I said, automation is a data-driven process. We all have hunches about things. And sometimes hunches aren't the most cost-effective things to follow in automation. You want to have your hunches at a minimum backed by data. And automation technology and discovery tools like process mining, and you're looking at a process map here, is a great way to start an automation journey. Turn the lights on, see what's really happening. And the thing I like about this is that it starts with business from the top down. It allows businesses to kind of play with the system by creating a digital twin, by instrumenting the key systems associated with a business process, collect data over time, analyze, correlate activities and tasks related to a business process, and map it out as the first pass of a journey. So now that you have this digital impression of a working system, you can start running simulations, doing what ifs, and even scratching your head and saying, why is this blue task executed so many times? It's not consistent with my intuition. Or why is it taking so long, right? So the questions become possible targets for optimization with automation. But also what you can do is play games, as I said, where you can actually script out using a business process notation map what you are inclined to think the process is. Submit that to the system as quote unquote what you think the answer is. The system can mark in green and red what it really truly sees the answer being. You can say, okay, you were right on all these three steps, these green steps, but this red step, it didn't make sense. That's probably not there. You should go check it out. So again, turning the lights on, using analytics to look at a business process and the opportunities. In fact, at this point, the hotspots, you can look at targeting RPA bots, you can simulate those bots. And before you even actually make a change to your system, you can pretty much have a reasonable expectation of what the return on investment is doing. And that's a big deal because you're kind of, building out your business case along with what you do. So this ability to observe, in a way that kind of shifts right to business, left IT, right to business is really impactful. So, now by joining business and IT together, you get a scenario perhaps like if a node goes down on one side, on the other side, due to this automation, you're instantly reaching out to customers based on loyalty, based on the profit associated with the outage, and with that level of awareness. So a node goes down, your IT operations bot detects that, triggers information from a service reliability bot that realizes that one of 4 instances of a payment service was affected, that then brings in business insights, maybe from that process map to say, oh, geez, there's 300K at risk on that payment node that went down associated with 50 clients. The business operations data can be enriched to say, again, the value of a particular customer interaction, the loyalty level, so that when you trigger an automated action, those bots are doing it with business impact and priority top of mind. Anyway, you get the site. So turning the lights on is probably the most critical place to start. Let me quickly go through 2 more examples and then turn it back over to the next panelist. Being able to make proactive decisions. And I'll embarrass Rama. This is her genius at work, working along with our IBM research group. So with this change risk model, and what I just said, the last one was an example of shift right IT to business. This is a bit of shift left at work, where you're shifting your IT insights over earlier in the stream of software delivery and development. Figuratively, with this change risk model, you can assess the change that a developer or an ops lead is about to push out into IT and say, IT leader that's pushing this change out, maybe through a Slack bot, you're not going to get to that baseball game that you have scheduled on your calendar tomorrow night, because if you push this change out, there's a 95% chance that you're going to miss the game because that change is going to cause an outage. Click here and we can explain why, right? So this is being able to take structured and unstructured data from relevant sources, unstructured sources like tickets from SRE Slack channels, and kind of linking that together with structured data from application topologies, metrics, et cetera, creating a ground truth from that linkage based on past historic data, using that to train the model so that when, again, an approval comes in for a change, you can trigger that risk alert, like I just said, right? So getting proactive, it's a big deal because where much of the world is still measuring success as improving response time to incidents, this thing allows you to avoid the bloody incident in the first place. So it's big, pretty powerful stuff. All right, let me quickly go to my last example. Rama alluded to orchestration and this Watson Orchestrate. This is a big deal, something we're pretty excited about. And it's really kind of putting automation in the hands of a much broader business set of users. And if you think about this Watson Orchestrate, one way to think about it as through an example of Alexa. So Alexa, I can say, tell me the weather, and it'll examine the natural language, kind of pull out the keyword weather, match that up against a skill that you have loaded in your Alexa app, and then it'll, with 98% certainty, say that's what this person wants and execute the weather. No orchestration going on there per se. But now let's say something Alexa can't do. If you wanted the weather in French and you had a French to English translation skill, right? Now you ask.
Jerry,
yes.
Jerry, just a quick 1-minute warning.
Okay, I'll wrap up in a minute. could I have the weather in French, right? Well, with Orchestrate, what you'd be able to do is kind of say, okay, there's two keywords, there's two skills. Let me execute the first, pipe the result into the second, voila, the weather in French. All right, let me just jump to, in the last 45 seconds, a more business relevant example. So say you have a sales executive who is looking to create a churn report, right? Jane Doe can send an email or Slack or however they want to respond in natural language to Watson Orchestrate to say, can you please send an email to account representatives that have customers with subscriptions up for renewal, where those subscribers reported problems with our service. So trying to get the sense perhaps for a customer churning. Well, what Watson Orchestrate will do is it will score, based on the natural language analysis, score, sequence, and then ultimately execute skills, business skills now from ServiceNow, Salesforce, Workday, and ultimately Outlook to create that report. Right? So the ability to introducing this notion of a business skill, and with that has either techniques around products like you see there, but also matching that with natural language to be able to compose, a response out of a fairly complex. So this is like programming without coding, right? So imagine what this would do. So anyway, long story short there. This is a summary, the process of automation and where AI powering could come in across this process. Anyway, thank you for your time. I appreciate it. Back over to you, Roma.
Thank you so much, Jerry. That was very insightful kickoff to our business process panel. Thanks for also sharing that Discover, Decide, Act, Optimize framework for thinking about how AI can power automation. So we'll come back to discuss this and other thoughts, Jerry, at the end of this session. Thanks again. Now I'd like to invite Professor Marlon Dumas to come and share his thoughts. So a little bit of introduction about Professor Marlon Dumas. He's a professor at University. I'm sorry, I'm bringing up here. University of Taru at Estonia. Sorry about that. He's a co-founder of Apromore, a company dedicated for developing open source process mining solutions. His research focuses on data-driven methods for BPM, including process mining and predictive process monitoring. And he's currently the recipient of advanced grant from European Research Council. And Marlon, with that, welcome, and looking forward to hearing your thoughts.
Yes, I have a little bit of a problem. Zoom is saying host to disable participant screen sharing.
Apologies, Marlon, try now.
I'll try now. Okay. Oh, we are all set. Great.
Perfect.
So thank you very much for this invitation and to talk to this audience. It's really I'm gonna really follow up on what Rana said and what we have just heard with Jerry and try to tell you about my experience on this road towards what I call AI-infused process execution. So I'm going to start by saying where we are at with respect to, let's say, techniques for process monitoring and process mining, like the ones that Jerry just spoke about, right? So, I mean, these techniques, what they do is that they take historical data from databases, from all sorts of enterprise systems, possibly also some live data coming from IoT systems. So, like, for example, data coming from your fleet management that tells you the locations of different employees, across town. And using that information, they create a number of insights into the performance of the process. If we talk about process mining, for example, it will create process models out of your event log, and then you can simulate those process models in order to do this what-if analysis. What if I make this change? What if I make that change, etc. That's a very good step towards, like being able to predict what is going to happen if you make a change. From this same data extracted from enterprise systems, process monitoring and process mining tools can create very sophisticated performance dashboards or performance enhanced process models that tells you what is happening in your process, where are your bottlenecks, where are your sources of waste, of rework, of defects, etc. And you can also use them to generate, to check compliance of your process and to generate all sorts of performance reports with respect to different types of regulations, or you can use them to compare the performance of your process across different segments of your organization. For example, for 2 different customer segments, I would like to know, why am I performing better for customer segment 1 compared to customer segment 2? What is it that I am doing for customer segment 1 that is making me get a better NPS score out of that segment? So existing techniques in the field of process monitoring and mining allow you to get comparative dashboards and reports of diagnostics of root causes for various problems that you might be experiencing. They are excellent tools for tactical process management, and they are used very widely. And at Promote, where I am co-founder, it's a process mining company, we see a lot of uptake worldwide, particularly lately in the US, on the use of process mining techniques. But process mining techniques, if we see it from the perspective of the 4 layers of analytics, from Gartner, is traditionally focused on descriptive analytics, so explaining how the process is performing now, and diagnostic analytics to some extent, trying to give you an understanding of what factors make it that your process is performing better for one segment versus another segment, for example. What we are seeing in the past few years is the emergence of a new set of technologies that embraces the upper layers of this analytics stack, including predictive analytics and prescriptive analytics, and that is trying to bring those techniques driven by artificial intelligence methods into the field of business process improvement. And among those techniques that are emerging, the ones that, I try to conceptualize this landscape of techniques that are emerging, I kind of conceptualize it into 2 layers. So I see a lot of techniques emerging that are trying to help operational managers improve the performance of the process on a day-to-day basis. One of those technologies is predictive process monitoring, which I am going to elaborate a little bit on, and that allows me to basically use historical data to build machine learning models that allow me to predict at runtime what is going to happen in my process, in a particular process instance, or what is going to generally happen in my process in the next 2-3 days, for example. And based on that, I can, operational managers are able to reallocate resources or make adjustments to the way the process is being executed in order to cope with different changes in the environment. Beyond predictive process monitoring, I am seeing a lot of the emergence of prescriptive process monitoring, which is turning your process monitoring engine into a recommender system that is recommending you actions on the basis of predictions. Like, for example, I predict that something will go wrong and I recommend to do a certain action in order to prevent. For example, reallocate a resource in order to prevent a certain SLA violation. And perhaps equally exciting is that we are seeing the emergence of a lot of AI-infused techniques at the tactical level. One of those trends is robotic process mining. And what robotic process mining is bringing to the table is the ability to record and monitor what workers are doing on their daily basis. And I'm talking about recording, 100 people in a call center working for, let's say, 2-3 days. And from that vast amount of data to discover automatable routines and to synthesize robotic process automation bots that can execute those routines. And finally, and what keeps me awake at night is all the developments we are seeing around automated process improvement, which is taking data from enterprise systems, event logs, the same type of event logs that we do using process mining and trying to automatically uncover problems in your process and possible resolutions. It's like process mining, but automated by AI techniques. Like if the bot was doing the process mining for you, finding out what is wrong and recommending you what to do in order to address those gaps. I'm going to briefly talk to you about ongoing developments in this field. So first, predictive process monitoring is a technique that is already at a quite mature state, and that allows you to look at your running process instances while they are being executed and to predict a number of things. I can predict, for example, the outcome of a process. Will an invoice be paid or not on time? I can predict SLA violations. Will this insurance claim be paid in 5 days or more? I can predict what will happen next. What will be the next response that the customer will send me. For example, if I make a loan offer, how likely it is that the customer will accept it, and when will they tell me whether or not they will accept it? Well, that allows me to allocate resources in order to be more responsive towards my customers and have more responsive customer service. In our group, both at Apromore and at the University of Tartu, we have conducted a number of case studies. For example, we helped an invoice recovery company, a debt collection agency, to improve their invoice recovery process by using predictive process monitoring. We just took their invoice recovery process, we took all the steps in it, we took data from their CRM and their ERP system, and we combined it with data that transcripts of phone calls that their debt collectors were having with their customers and of emails that they were exchanging, and we put them into a predictive monitoring engine, and we were able to detect with relatively high accuracy which invoices were going to have to be sent to encashment, which means to the bailiff, and which invoices were going to be paid by the customer, within 2 months. And that helped them to reduce the number of invoices they sent to bailiff, which is something they want to avoid because, of course, it means that they actually recover less money than if the customer actually ends up paying the full amount. We have helped, for example, claims handler, the claims handling department of a large EU insurance to analyze their motor vehicle processes and to build a predictive monitoring dashboard that allows them to anticipate SLA violations in their claims handling process. And in that way, we got a double-digit reduction in their SLA violations. And we have helped a logistics provider to have a predictive monitoring dashboard that allows them to anticipate delays in package delivery. So we take historical data about their package delivery process, and we put it through predictive monitoring techniques that at runtime are constantly looking at the location of each package and its historical data and telling you which packages are going to be late. And this allows managers in this logistics company to get dashboards every morning at 8 o'clock, telling them exactly in their region, how many packages will be delayed and in which areas for which type of products and for which type of customers. So in all these case studies that we have conducted, what the 3 challenges that come all the time and that customer says, this is great, but it's still not there to be, to deliver its full potential is because of 3 things. One of them is the explainability of the prediction. Managers not only want to get a prediction of this package will be delayed, they want to know why. So that's something that it's a very, very rapidly evolving field called explainable AI that allows you to not only produce predictions, but also tell you exactly how different factors contribute to this prediction so that you can make more informed decisions about what to do next. But beyond that, what we are being asked by users of predictive monitoring dashboards is the ability to turn predictions into actions. So to determine what actions should they do in order to reduce the SLA violation. And to be more fine-grained than just saying, oh, when the probability of a late delivery is 60%, then you should allocate the resource you should escalate it to a resource. They don't want that. They want that out of a panoply of possible actions, you are able to tell them which actions are more suitable for this particular package given their particular circumstances. And beyond that, what they want is say like, yeah, recommendations or predictions are great, but I want to at the end, I want to maximize some performance metrics. So they want like a predictive monitoring engine that is aware of costs, aware of revenues, and that can recommend decisions that are going to ultimately maximize the net gain from this business process. And that engine that is able to address these three questions that I have here is what we call a prescriptive process monitoring engine, which takes a predictive model that has been trained from historical data, takes data about an ongoing case of the process that has not yet completed, makes a prediction, and using some cost model provided by a manager, recommends what to do next and gets feedback back from the manager to improve those recommendations over time. We see a lot of techniques being tried in this field, particularly from an area called reinforcement learning, and we are going to see a lot of developments in this field definitely in the next few years. Now, what keeps me even more excited than prescriptive process monitoring, prescriptive process monitoring is going to be a technology that will hit the shelves in 2022 to 2025. But what keeps me excited is what's coming after that, which is what I call automated process improvement. You have data from your enterprise system, you extract it in the same way as you would for doing process mining, and you can from there construct models of what will happen if I make a change? That was what Jerry was talking about. What will happen if I allocate one more resource to a resource pool? What will happen if I skip this task, etc.? But instead of you doing it manually and saying, what happens if, what happens if, what happens if, and then out of 5 scenarios, picking one and implementing it into your process automation engine, the idea of automated process improvement is that an AI, a search-based process optimizer, will try thousands and thousands of different combinations of changes to your process and will recommend you the optimal combination of changes to your process that will improve the performance metric or the KPI that matters to you. And what kind of recommendations this engine can generate? Well, it can tell you, for example, in a loan application handling process, that for consumer loans, you should execute certain tasks earlier, because those tasks generally lead to errors. For example, you find that the customer is not eligible for the loan. So you can stop the process before and you can have a more efficient process. Or for example, that certain tasks are better skipped for certain types of loans because anyway, they have been performed recently for the same customer. Or
Marlon,
yes,
Marlon,
yeah.
Apologies. This is so fascinating. I hate to do this, but I'm giving you the 1-minute warning. Apologies.
Oh, 1 minute is okay. I'm almost done here. Yeah. So, and what allocate, like, what if I have more workload on Mondays and Tuesdays in one part of my process and less on the other? So this is recommending that you reallocate resources on different days of the week to different areas of the organization. And more interesting, and this is relevant in the context of RPA, is detecting that this task that you're seeing here, given the recordings I have of how people perform that task, can actually be automated by an RPA script and synthesizing the documentation or the actual script so that you can deploy a bot to automate this task. And basically this slide summarizes where I think we will be in between 2025 and 2030 as the technologies for automated process improvements that are being developed in the labs, be it, for example, here at the University of Tartu or at Vander Alst group at RWTH Aachen in Germany, these techniques are going to revolutionize the way process execution is taught and are going to lead to a convergence between process monitoring and process automation. And with that, I give the floor to the next speaker.
Thank you, Marlon. That's fascinating. Thanks for bringing up the progression from predictive to prescriptive, and really interested in knowing more about automated process improvement. So as part of the panel discussion towards the end, we'll come back to you on what kind of processes are amenable for automated process improvement, and what are some of the challenges that customers are seeing. So thanks once again for presenting. We'll now move on to our next panelist, Professor Vander Alst. I hope I've said it correctly, Will.
Perfect, Rama.
Oh, thank you. He's been a full professor at RWTH University, Aachen University, leading the process and data science, that is PADS group. He's also a part-time affiliated professor at the Technical University in Eindhoven, widely published, widely quoted, respected researcher who is considered the godfather of process mining. His research interests include process mining, Peternet's BPM, workflow management, process modeling, process analysis, and such. He's an ISSIP fellow, IEEE fellow, ACM fellow, and elected member of Royal Netherlands Academy of Arts and Sciences, among many other credentials, which are far too many to list here. His work has also gone into many products, process analysis products, including Celonis, MineVinio, Eris process mining, just a few products to name. It's a pleasure to have you here, Will. The floor is yours.
Yeah, thanks a lot for the kind words, Rama. Yeah, so the title of my talk is intended to be a bit provocative, let's say, for the discussion. So I'm putting things perhaps a bit more extreme than I really mean them. What Jerry talked about in the beginning was that, let's say, automation is not a new topic. So for example, next week I'm having a meeting with Michael Zisman, who implemented, let's say, the first workflow management system in 1977, and also had for quite some time an important role within IBM. There was also the Flowmark system that I think many people remember. So there was this, let's say, optimism, and there was this vision that workflow management technology, and what was later called BPM technology, would be the same as a database system. So you put your data in a database management system, and then that system manages your data. And there was the vision, and I shared exactly that vision, let's say in the 90s, that workflow management technology would take care of processes, just like database systems take care of data. So I strongly believe that, and I was very optimistic about it, and I believed in it. I wrote, let's say, also in the 90s, let's say, a textbook on workflow management, but it did not happen. So I would not say that it was a complete failure, but these things were not adopted as common as I and many other people in the field expected. So what has happened is that over time, BPM got a bit of a negative connotation. It didn't have a very, although the research that was being done was very great, but people in practice, they did not believe in it anymore. So for example, I gave several keynotes at the Gartner conferences, and the Gartner BPM conferences do no longer exist because people did not believe it anymore. And there were many talks with the title that you see here, and if people say that, then you know that there is a problem, right? That was there. So why did BPM not take off in the way that I and many other people expected? I tried to make an analysis of that, and like classic BPM got a bit of a negative buzz associated to it, that it is expensive, and that people are just making, let's say, wallpaper with flowcharts. So in my view, there are three key problems of classic BPM, like what I also did myself. The first thing was that we underestimate human behavior. We think about many processes as being very simple and you can easily automate them. If you do process mining, and I think many people in the panel and in the audience have had that experience, only if you do process mining, you realize how complicated processes are and how how flexible humans are in doing both good things and bad things. So even if you look at simple order to cash, purchase to pay processes, in larger organizations, you will find thousands of different ways of executing these simple processes. So we underestimate human behavior. We also underestimate the complexity of the data side of information system. So my belief was, okay, SAP should simply, I don't know, invest more in workflow technology and everything will be fine. To be very honest, I did not realize, for example, if you look at SAP HANA, that there are 800,000 different tables filled with information. So to think that you can make a flowchart and that will all be managed is I think, very naive in hindsight. And then, and I think that very much refers to, let's say, the last point that Marlon made. The goal of BPM is to create really real process improvement. So insights need to be turned into actions and you need to be able to measure them. And I think many traditional BPM initiatives got stuck in, let's say, documenting processes without being able to show these actual effects. So this story could end, let's say, very bad, like BPM is dead, so why bother about it? I think there are two important developments that make that BPM is completely vivid again. It's again coming back in let's say, many mainstream discussions. And I think there are two main reasons for that. The first main reason is, let's say, process mining. And I think process mining was very much initiated from academia. Another important development where academia can absolutely claim no credits was RPA, like a different way of looking at automation that was very much, let's say, triggered by industry. And I think these two developments, they address the issues that I was making before. And I have some slides to kind of to support the claims that I'm making. So first of all, everybody knows that in processes there is an 80-20 rule. If we look at all of the behavior, like here, I just take a few activities of the purchase to pay process in SAP. If you look at all the behaviors, all the different cases, then you see something like this. If you focus on the 80% of the cases that are executed that are following the most frequent paths, we get models that are relatively simple. And so the good news is that it's easy to generate, let's say, process models and insights showing the mainstream behavior. The problem and the challenge is that, okay, we know how most of the, let's say, happy paths run. We do not know, let's say, the remaining 20%. But the remaining 20% is causing all of the frictions in organizations. So this is the rework. This is where, let's say, organizations, let's say, lose money on. And process mining is able to make this visible. That there's no sense in looking at the happy paths. You need to look at the remaining 20% that is causing, let's say, all the problems that you see here. So I don't know if in the context of the purchase to pay process, suppliers that frequently change prices and by that kind of derail the complete process. So this is what process mining makes visible. And if you look at the life cycle of, let's say, a typical process mining activity, it starts with data extraction. One discovered the process models as they are really being executed. Based on the combination of both the event data and the process models, you can show, and I think the previous speakers have shown that, you can show exactly where performance problems are, like bottlenecks, or where compliance issues exist. And then I think Marlon very much, let's say, focused on the last part that he calls process mining 2.0, which focuses very much on this forward-looking, often in combination with, let's say, machine learning techniques. What I would like to warn the audience a bit for is that don't start at the end, right? I think many organizations do that, and I think these are just complete failures. If you have problems extracting data from SAP, don't talk about predictions or something like that. Or if you have like simple processes that have thousands of variants, don't talk about prediction. So start with, let's say, getting your processes under control. Start by getting the right data showing what is really going on. So if you look at the development, then like we started doing this research in the late 90s in Eindhoven, that led to all kinds of products and all kinds of techniques in the 90s. What we see is that the real adoption is very recent. And if you have, I think lots of people in the audience are based in the US, you can see that in the US even started later than what you see here. And so there it is a relative recent development that has a longer history than what some people may think. So the good news is that currently there are many process mining tools available. So for example, Marlon showed several screenshots of Apremore. Like here in Germany, of course, Celonis is considered by many the most successful young German IT company that exists. So there's lots of interesting companies coming into existence, or already companies that have been around that now embrace this technology. For example, two very recent developments, and now I'm talking about the last couple of weeks, are that SAP purchased Signavio for over $1 billion, and IBM acquired MyInvenio. And I think the Jerry screenshots were also from MyInvenio, if I saw that correctly. So you can see that there are young companies and there are existing companies that let's say embrace this technology, which I think is very, very good. If you look in Germany and in the Netherlands, you can see that process mining has already become the new normal. So all of the larger organizations are using process mining in some way. I realize that in the US that is often still not the case, but I think that is changing rapidly at this point in time. So that was something about process mining. Something that I think academia missed completely was RPA. So we got stuck kind of in this classical thinking of replacing something by SAP by something more modern, and that did not work out very well. So RPA for sure complements process mining, as I think also the previous speakers indicated. So using process mining, you can identify what are the things that you can automate. At the same time, RPA is typically bottom up, whereas successful process mining projects are typically top down. My take on RPA is kind of indicated in this picture, and that's a picture that I often use to explain to people what is the main difference with, let's say, classical workflow automation. People are, let's say, the glue between different systems. And so people, so for example, in the call center, it is not uncommon that people are working with dozens, sometimes hundreds of different systems. And people are the glue behind all of these systems. They are copying things from one system, another system, etc. The classical approach to workflow management is let's throw away these 100 information systems, and instead of having these 100 information systems, we build a new system that nicely executes these workflows. that in a way is very naive, because that's extremely costly. These systems are much more complicated than one thinks. And many of these initiatives fail completely. The idea of RPA is not to replace the systems, but to basically selectively replace the people sitting in front of these systems. And for the other people, you can immediately think about screen scraping, etc., etc. And so many would say this is not a new idea, but I think it is a new idea in the way that the RPA vendors successfully applied this, let's say, in practice. So a bit more about the connection between RPA and process mining. So this graph is showing how frequent process variants are. Then if things are super frequent, you can do traditional automation. If things are very infrequent, forget about automating them, just let people do that. I think RPA is this part in the middle where it is not cost effective to replace existing information systems and automate workflows in the classical way, but you can simply replace people sitting in front of these systems.
And apologies, 1 minute warning, apologies.
Well, perfect timing, last slide. So I hope I gave you some insights that yeah, BPM in the classical sense has some issues. What I think we can learn from that is that we should accept people and systems as they are. And what do I mean by that is we should use event data, so the behavior that is really there. We should, if we know that there is an 80-20 rule, we should not ignore the 20% because the 20% is generating 80% of your problems. And do not be very naive in the sense that you can simply replace all the systems that is there. If you're interested in learning more about process mining, which is the topic that I'm spending most time on at this point in time, there is a growing amount of books in this space, also in Japanese and Korean, etc., that you can take a look at. Thank you very much.
Thank you, Will. That was fantastic. And you've already covered the best practices question that I had as to what are the do's and don'ts in process analysis and process optimization. So that's great. We'll come back for more discussion and chit chat with you as part of the panel in just a bit. The last speaker in this session is Vic Soni. So let's move to that part of the section now. Vic is a senior partner with McKinsey. He's a leader in their digital practice and is part of McKinsey's digital labs in North America. At McKinsey, Vic helps companies across sectors on digital and broader technology issues at both managerial advisory as well as deep technical advisory levels. Vic has served several leading institutions in the Americas on strategic and digital transformation programs, resulting in major strategy choices and operating model changes that led to growth and efficiency. Vic is also a board observer for McKinsey's investment in the artificial intelligence for the company and leads their partnerships with several technology and AI and ML firms. Vic, it's a pleasure to have you. We're looking forward to hearing from you on your thoughts on business process analysis and how ready it is to transform and how AI can power process optimization. Thank you. The floor is yours.
I appreciate the introduction. So I think I have about 15 minutes, Jim mentioned to me, and I'll keep some of that for questions. Thank you, Jim, for sharing the screen. I can do it as well if something breaks down now. I switched devices. So I thought what I'd talk about is, but you should keep doing it, and if you're on there. I thought what I'd talk about is the practices that we see that companies are deploying or organizations are deploying to succeed in the automation space. So if we go to the first chart, what I think, just to cast this, there's certainly a growing trend towards automation, right? When it's defined more traditionally. Now, obviously, I don't have to tell all of you the world is rapidly digitizing, and just the COVID crisis has led to obviously a lot of that as well. and an acceleration. As one data point, one of my clients, which is a large bank, flipped from selling about 40% of its loans digitally and 60% through their branches and call centers. They flipped to doing to 60-40 the other way, right? Just in a year's time. And you rarely see those kinds of changes in a place like banking. And that's kind of what's happening. These data on the screen bear the same thing out, right? So you're seeing a big jump in trial for automation, as you can see here, where the black part of the bar in 2018 has reduced, right? And then the piece below the waterline, if you will, where they either not begun or have no plans to do so within the next year, that has shrunk, right? And the piece above the waterline has increased by about 9 points. But what is also interesting, and this is actually a really important point for this forum, is that the biggest change is in piloting. And so people are generally still in the mode of trial and toe in the water and seeing how it plays out, as opposed to actually scaling these programs. Because if you look at the top green box of 16 and 15, I mean, the percentages that are actually at scale are effectively consistent between the 2 years, right? And that's a profound message for every practitioner in this space. It's also, you know, when we had written this, I co-authored the paper I think Jim had sent to all of you on Burned by the Bots. You know, there's been some improvement for sure, but as a discipline, it's not changed dramatically. All right, let's go to the next page, please.
It seems to have gotten stuck, Jim.
I think it's frozen. So
yeah, I'm apologizing. I'm just trying to unstick it. If it doesn't work, I'm going to have to. Let me stop share and reshare.
Yep.
For some reason, it got stuck.
No worries. While you bring it up, I'll just introduce and talk about the next page. So what the next page has is you know, what actually then makes these things work, right? These programs. And we had some research that showed that I mean, not surprisingly, frankly, the defining feature of making these programs work, thank you, Jim, is to make it a priority for your company's strategy. Right? So you can see that the respondents that reported successful automation efforts, this is the first bar at the top of the page, were those that had defined it as a priority. And importantly, for the ones that didn't have success, right, it's a missing factor, right? So at least by dint of absence as a factor, you can infer that this was potentially contributing to the lack of success. On the flip side, if you look at the 32% of we needed to improve our cost base as a reason for doing a program, you'll see that was potentially, again, inferred as a contributor to not succeeding. And I think Jim mentioned that you guys have covered this in other sessions, but I will reiterate to you my personal experience as being a practitioner on the front line of many programs with different companies across sectors, is that when you try to automate for cost, you often fail. And the reason is, it was covered in my white paper as well, is there's the fingers and toes problem, there's the localized bottleneck problem, there's the problem that cost as an outcome is not inspiring people like passion and purpose to be productive. And if you try and do things for cost reasons, which of course we all have to at some point, it takes away that passion and purpose from people's lives, and they become actually less productive. So you might get some points on the board with automating some things, but you have a workforce that's demotivated, and that actually often counterbalances it. So for all of those pretty complex managerial reasons, you see that this is a very interesting finding, which frankly goes against the grain of a lot of the selling points for vendors in the space, right? You're saying, listen, there's a clear ROI, we'll take cost out. No, it doesn't happen. It may happen in a localized instance. When you try to scale this program, as you saw on the previous page, it doesn't work. So then that teases a question, okay, then why do this, right? And it's a cool tool, right? But hard-nosed business people need real business results to invest real money and spend their budget. So if we go to the next page, you'll see that where this actually starts to pop is other reasons for making this work. Now, I'll tell you, and McKinsey is not into selling software, so we can be pretty objective about this stuff, which is that it's a squishier business case, right? And things like faster service, increased flexibility, improved quality, better experience, you can draw straight lines to the bottom line, but it's a squishier line, right? If you will, it's not as easy as saying, listen, we took 35 heads out of this cost base, right? And no, people don't like to have these kinds of conversations often because it's not a clear, open and shut business case, especially when you want to spend money on the other side. But this really is where the bang for the buck is. And so I would urge all of you, as you think about your programs and folks that you work with and advise and so on, to bear this very strongly in mind, which is the way to get a workforce motivated, the way to automate things, the way to move to the next level, is to paint an aspiration. Get the workforce to think big. Don't try and cut costs beyond obviously prudence, and you need to keep a business going, of course. But that's not the reason to automate. And then if you look on the other side of the coin, there's a bit more research on the next page. And you see, this is an interesting depiction which shows, let me orient you all to this page, which says that there's, again, looking at two rows. The first top row says respondents reporting successful automation efforts. And then how did they go about it, right? And then other respondents who didn't report successful automation efforts, and there's obviously an overlap with the ones that it didn't really work out. You'll see that the biggest difference in terms of the path to adopting automation or scaling automation is through the second column, right? That's where the biggest delta occurs in human in the loop solutions. Right? And so rather than saying, listen, we're going to systematically redesign your processes. And we do a lot of that work, and it's very virtuous work. It actually has impact, right? To systematically take an end-to-end thing and say, listen, from start to finish as the value stream where the demand trigger occurs to the supply fulfillment ends, we're going to debottleneck that entire thing, use lean principles, operations principles, streamline the flows, not just work the happy path, work the other parts of that. But the biggest, and so all of that works, right? Tactical interventions work too. There's a pain point here, this call reason we're seeing in our call centers showing up. We got to, change that. All of that works, clean sheeting works, but the biggest delta of success is when you have human in the loop solutions, right? And what is human in the loop solutions? It's that you have people being powered by technology, right? That's when these things actually work out. And so think of the technological solution as an exoskeleton, right? So it's like the Iron Man thing. It fits around the operator and it allows the operator to be more productive. I mean, the best example I've seen is in a production line where they had these VR goggles and the operators were looking at widgets that were coming out of the machine, and the VR goggle was helping them make sure that they were within tolerance limits. It was what they expected to see. There were a bunch of other aids. We still had people in the loop, and they were becoming dramatically more productive and dramatically more happy and satisfied as employees. And they felt the company was investing in them. And they felt that their jobs were not insecure, right? They felt their value was increasing in the market. It gave them purpose. It felt like they were they were special, right? They were different from other people in the marketplace. They were on the forefront of cutting edge technology as users. And they were helping shape and input to the way that technology was being deployed. So you get the broad idea. And so the last thing then I'll pause is on page 8, Jim, if we can skip the next page. There's a bit more about that. Is Jim, if we can move to page 8, please. Next page, please. Page 8, page after this one. Thank you. So this is McKinsey's tried and tested approach to influencing change. Right? And it's a simple framework, which I have through my career of 20 years doing this at McKinsey and 4 years previously. I didn't know this intuitively back then. I didn't know this back then formally. I knew it intuitively. I learned this when I came to McKinsey. It's a very powerful framework. It says, listen, if you want to actually drive change, there's 4 things that need to happen. You need to have people role modeling that change. It's the Mahatma Gandhi, be the change that you want to see. You need to be able to foster understanding and conviction and have a clear story that motivates people. And there's, 5 different types of stories. There's, I want to change because of my company. I want to change because of my team. I want to change because of the product I sell. I want to change because of the values that I have, right? So there's different types of motivational reasons why people want to change. There's incentives, right? And that's just not monetary, it's non-monetary. It's also barriers that people have, even things like which shift operators work in. And then it's the skills, right? And training. And as we think about automation programs, and as we think about driving productivity, which is different from driving cost reductions, as I've emphasized through this presentation, having a holistic view of driving change management is critical to making these programs work out. So with that, let me pause there, see if there's any time for questions, but I thank you for listening to me. And clearly there's a lot of momentum in the space, so certainly a lot of good that can come out of all of this. Thank you for that.
Thank you so much, Vic. That was very insightful. It's refreshing to hear from analyst perspective, especially as somebody who has worked with many companies and helped them with the transformation and help them get there, and the best practices and some of the people side of and the cultural side of things that you have shared are very insightful. Thank you once again. So this concludes the panel speaker session part of it. We have about 20 minutes, I guess 15 to 20 minutes. We'll open it up for everybody to ask questions. I will start off with some of the panel questions that I had prepared as a way to get the discussion going. Others who have questions, either unmute yourself and ask it or put your question in the chat section, please, and I will moderate it and I'll ask those questions. So let me bring up the panel questions that I had. Okay, so I want to start out. So there are a bunch of things that we wanted to discuss. I want to start out asking Jerry this question. Jerry, you talk with a lot of customers and advise them on their journey to automation as you bring, what IBM is bringing to the table to help customers in their journey to automation. Can you share with us on what are some of the challenges that you see for our customers, for companies, when they try to automate anything, automate, optimize, automation is the broader term we are using to basically optimize their business processes. You talked about a bunch of processes in financial services. What is stopping many of those companies or customers from achieving that process optimization and what AI can bring to the table? What are some of the steps that they have to take, or what are some of the challenges that you're noticing?
Well, and Rama, even in the last 6 months, I've noticed the resistance to change has greatly reduced. I think this, with everything going digital, with people working remotely, the dependency, the interest, and quite frankly, the shift in budget towards automation and AI is quite noticeable. So I would say there is a tone and tenure change that we're hearing back from clients, some going as far as saying this is the year of automation, and that's kind of what they mean by it. But everyone is accountable for results. And I think some of the cautionary tales is don't be too quick to mix or create such a big North Star around automation that you oversell your audience. So for example, if you're talking to an IT-oriented clientele, talk about IT optimizations. I found myself excited to talk about the shift right and shift left too early before I think they've even appreciated what it means to them in their role. Now, if you go higher up and sell higher up in the organization, there may be more acceptance to that message. So that's, be mindful of who you're selling automation to. But in all cases, be mindful of to keep their enthusiasm. There is this perception that, especially when you bring AI, machine learning and training and things like that, that they're in for a long journey around automation, right? So, having that North Star is good, but have the Apollo program, like the missions along the way to get there. And those should be incremental with return on investment. This is why, and this is why I thoroughly enjoyed listening to my co-panelists, topics like process mining resonate. The businesses usually have the budgets. It's a very targeted business proposition. And also you can break it down to bite-sized pieces that matter. So you have that incremental ROI. You can even in a digital twin scenario simulate what that might be so they can put that cost against what they're spending on the tools, on the service time, et cetera. So, dream big with the Apollo program, but don't spook the customer, create that incremental path around smaller project ROI. And I think that tends to work the best. And process mining seems like a great place to start on the business side.
Yeah. That makes sense. Show value in small segments, small increments, and build it up to the bigger vision eventually. And that makes a lot of sense. Marlon, I wanted to pick on the last part of the presentation in the presentation about automatic process improvement, right? What are some of the things that should be in place from a process analysis tools perspective to enable that automated process improvement? It seems to me that, for that to happen, there has to be some kind of a, not only observation, real-time observation about the processes, but some notion of self-reflection of, where are the hot spots, what's wrong and all that. So there seems to be a whole paraphernalia that's really required in this process analysis tools to make such an automated process improvement happen. Can you talk to that as to what are some of the things that both industry and academia are working on, and what you have seen, and which ones are prime ready and which ones are still ways away?
Yeah, I would like to start by echoing Will's message that before you go into the AI-infused process execution or process mining 2.0, whatever you want to call it, using predictive techniques and automated process improvement techniques, you need to have the fundamental rights. You need to have the data there. So, you cannot go around it. You need to know how to extract the suitable data about your processes from your ERP, CRM systems, etc. You need to have done some prior analysis to understand where you are. So doing some process mining before moving into automated process improvement is a must in order to have the idea of what you can change and what you cannot change in your process to get the boundaries of the change. And you have to have a certain business process backbone. Automated process improvement, I don't think will in the next 10 years be able to design the backbone of your process. The backbone of your process is your intellectual property. It's what managers and analysts together build over a number of years. What automated process improvement can do in a way is to tune the process, to adjust the allocations of resources, to adjust the decision rules, to adjust the way, the order of activities in order to get you closer to achieving certain performance objectives. So I think that is the main message. I could say other things to reply to your question, but really that is the main message. It's like get the data, get the understanding with process mining, process discovery, and performance mining, etc. And then on top of your existing backbone, which of course you have to have designed it using traditional business process management techniques. Automated process improvement can leverage, can enhance it, can find the fine tuning that is going to bring you into continuous AI-driven improvement of your processes.
So very much, yeah, keep human in the loop and understand the rich intellectual property that companies have, and really pick the ones that are amenable for such automation versus the ones that still need to be very much run with human in the loop, still guided by AI and automation is the message.
Yes.
Yeah. Will, I wanted to ask you about process orchestration. You touched upon RPA as an industry-driven initiative and process mining and analysis from academia perspective. Now, there is process orchestration is also gathering a lot of momentum these days. But as somebody who has been through this in the early 2000s with web services and what were at the time registries that will capture web services and web services composition and semantic labeling for web services and all that, and mashups. All those things came up, but they didn't take off, and they had very minimal, if any, impact in the real business use cases. This time around, do you think process orchestration is ready for prime time? What are some of the IBM introduced this Orchestrate, as Jerry and I both referenced it, and we're starting to see some use cases, but you also talk to many companies and have built products and drive research in this space. Are we ready this time around for process orchestration? Are there really business use cases that are amenable for such automated orchestrations?
To be very honest, I'm a bit skeptical there. That was also a bit the flavor of what I tried to convey, is that you do not really understand what is going on, and you cannot embrace the entire complexity of what is taking place in systems like SAP, etc. I think this is very difficult. Of course, there will be use cases. At the same time, but that's a different type of technology than automatic process orchestration. I think if you look at RPA, that is giving a new spin to automation, right? That you replace people rather than that the focus is on replacing systems. What I also think, and I think that also was a bit linked to let's say Marlon's comments at the end. I think if we look at the goal is in the end to improve processes, right? Processes that run okay, you don't have to do anything. So if you are able to identify what is not running so well, the fact that things are not running so well in a repeatable way, you should use that to create workflows that try to address these problems. So what you now see is that many, let's say, more advanced companies that are applying process mining are combining process mining diagnostic with, let's say, low-code workflows that people can draw. And to be honest, I think that is more promising. I think also, if you look at the interorganizational setting, I think there is a big opportunity for what you could call interorganizational process mining, right? I think, so if people talk about supply chains, etc., it's clear that you need to think along the entire chain. At the same time, I don't see that many companies that are willing to share the data at this point in time. Going across organization boundaries, which serves as good support. Like if analysis is already difficult, then automation is typically not such a good idea. But perhaps there are new and interesting things that I did not see, but I'm a bit skeptical, to be very honest.
I understand, and the interorganizational data sharing actually is a huge problem. We see that all the time. Jerry was talking about shift left and shift right, and if you take shift left itself in IT operations space, we see that operations teams and the development teams are different. So when you start shifting left into the development operations of those IT systems, how do you make sure that you get that data and actually share and build these, these feedback feed forward loops? There itself, it starts to get difficult because the decision makers are different, organizations are different.
My main message will remain that if you really are open to looking at the real processes, in most organizations, there is still such an incredible potential that you should first get that in control before talking about more advanced stuff.
Yeah.
That's of course perhaps not the most sexy things to do, but at the same time, I think, yeah, if your data management is not in control, forget about anything else. And if your data management is in control, it is a push of a button to get these process mining results.
Yeah. Thank you. And Vic, I wanted to ask you, you have so eloquently pointed out that, it's not just about cost. Automation for cost is not inspiring in the organizations, and you're really focusing on the quality and the customer support and improvement and process efficiencies. Those kind of things are what are inspiring. Now, I wanted to hear your perspectives on this, building these bridges from whatever process optimization efforts that at a technical level organizations undertake to those higher level metrics, be it customer quality improvement of the process, or the customer support, customer satisfaction improvement, and those inspiring metrics as you talked about, building those bridges. How does that happen? Is it something that you think should be codified in the tools? Would that help the organizations, or is it a very, you think, continues to be a qualitative process that needs to be done? Is Vic still there? I cannot see.
I think Vic just had to drop off at 9:30. And Rama, can I give you the let's see, actually a 3-minute warning to keep us on schedule?
Yes.
We can end in 3 minutes.
Yeah, absolutely.
It's such a great discussion. I apologize.
Yeah, no, that's good. We have to be on time. So that's I guess Vic dropped. So with that, I'll open it up for questions. Anybody in the audience, if you have any questions, feel free to share your thoughts, perspectives. I know there are a lot of folks who do research in the space of process analysis and mining who are on this Zoom conference. So feel free to share your perspectives or pose your questions, please, to the panelists.
Short question, short answer, please.
I think I have a quick question, Rama.
Go ahead, Ralph.
As someone on the East Coast who's wondering if he can fill up his tank with gas this afternoon, I'm wondering about, in the design of these systems and in the project plan for implementing these systems, how much thought is being given to resiliency of these automated intelligent processes?
Anybody want to take that? Jerry, Marlon, Will?
Well, I think that I'm not quite sure that AI is the right technology for resilience and reliability, etc. Right? Quite the opposite. You might need to put some boundaries to it to achieve resilience, but it gives you some adaptability. And if you put it within the right boundaries, it can adapt your process For example, as the demand increases, let's say that you get 2 times more orders next week than you were expecting. Or let's assume that, 10% of your employees cannot come, because of COVID next week. So, that's there is where AI can help you to plan ahead, to do like automated prediction, automated tuning that can allow you to handle that kind of slight deviations. But you have to see, like, you have a system is stable. If you perturb it a little bit, AI can help you to manage that perturbation. But you cannot count on AI to make major changes, because that actually is going to affect the resilience of your process rather than enhancing it.
Thank you, Marlon. I think that's it from time perspective. Yeah, we'll conclude this session here. Very insightful. Thank you, Jerry, Marlon, Will, and Vic for sharing all your thoughts and ideas on this topic of AI for business process optimization. Appreciate it.
Yeah.
So Jim, I'm handing it over to you. Is there a break, or are we continuing on?
I think we're going to have to take the break as we can. I apologize to everybody for that, but I want to try to keep on time because I know certain people have very tight calendars, including Dick, who was able to join and drop off. So with that, I would like to just introduce our next moderator, Terry Griffith, who is ISIP's Vice President. And Terry, please introduce yourself and the panel, and we'll take it from there. Over to you, Terry.
All right, just coming up. All right, I think I'm ready to go. So thank you so much for this opportunity to learn from the prior panel, and I'm very excited about the second one. Digital twins of service systems, and certainly some of those with robots, are being created across industry and government as part of the AI and variety of automation projects. And successful AI and automation, as we just heard, we have many use cases where we are seeing quantifiable benefits. However, as you've likely seen in your own work, and even as we just heard in the prior panel, there are cases where the AI or the automation project more broadly started, stopped, under-delivered. And I'm very much looking forward to our 4 panelists and their presentations across very different kinds of examples. And I'm going to keep this very brief and just say that throughout these talks, I'm going to be looking for what I call the 5 T's in terms of how these projects are put in place. And with that, a target, what are we actually trying to do? What's the talent that needs to be leveraged in this situation? What technologies, this is going to go without saying, and then the techniques that we're bringing that talent and technology together, all aligned for the times. And so I've got my checklist ready here, and I'll be looking both for the individual examples as well as those interconnections. I'll also be tracking the chat so that when we get to the later sections, I'll have some questions to bring up for each of the panelists. But let me also do one plug. Each of the presentations that we're seeing today is a perfect example of the kind of proposals that we're hoping to see for the HICS conference in 2022. So HICS is one of the top information systems conferences, and it's the Hawaii International Conference on System Sciences. So what could possibly be wrong about a conference in Hawaii in January? And what ISIP is doing is we're specifically looking for practitioner insights. So 3-page executive summaries to be proposed by June 25th. There are paper awards, and it will bring this community back together again in an even more lovely setting than Zoom. At least that is the plan, that it's a physical face-to-face event. So there's my pitch. Please do take a look at that short link. And I know Jim's going to be sharing the slides for all, but let me go ahead and go to our first panelist. Ooh, that's interesting. I'm not sure if that's me.
So let me check. Somebody may have dropped and not gone on mute. Sounds like it. Oh.
All right, thank you. Thank you so much. So first off, we're going to have Sean West. And Sean is from the Hochschule Luzern, where he teaches and leads research in the field of service and service innovation. His lab uses visual interactive approaches to problem solving and building human-centric solutions. So let me stop my share and give the floor to Sean. Sean, actually, you may be able to take it yourself. There you go. Yeah, Sean, might you call in? We'll just take a moment. Yasi, thank you for putting that link in. I will put the direct link to the call for papers as well. Yeah, he's working it. Let's see. Sean, would you like me to go to our next presenter and we'll take you as number 2? Oh, it seems to be better. Oh, but we're not hearing you.
Yeah, I think
All right.
we better go. Sean, you and I can work on the technical difficulty. And Hausi, are you ready to go?
I'm ready to go, yeah. If need be.
Please, if you have your presentation ready to go, we'll circle back
Well,
to
let
Sean
me,
and apologies.
yeah. So Hausi, let me do your introduction here.
I can't share the screen yet.
Yeah, just give me one moment. I want to give you an introduction. Okay. Professor Hausi Mueller from the Department of Computer Sciences at the University of Victoria in British Columbia. And if I look out my window, no, it's too cloudy. I can't quite see your mountain in the horizon there. But his most recent publication is on autonomic and cooperating digital twins in IEEE internet computing. So I know for a fact we're going to have some deep insights here. So let me stop the share. And it's all yours.
I still can't share.
Let's see.
Oh, maybe I'm not a co-host.
There you go. Jim just fixed that.
Ah, now it works. Okay. All right. Thank you very much. Thank you, Rama, Jim, for inviting me. Thank you, Terry, for this very nice introduction. I'm delighted to be here. So this is an interesting topic, digital twins. And I'd like to submit that we are all somehow very familiar with this notion of a digital twin. I think the most amazing digital twin design we have at our fingertips, if you like, is the cerebral cortex. The cerebral cortex has a copy of pretty much everything that happens in the brain. While technically unnecessary, this copy has immense flexibility with respect to our cognition. and is super helpful for us. So while the digital twin revolution is happening all around us, in large part, Jerry Como said earlier that automation is not new and digital twins are not really new. However, there's amazing confluence going on with respect to technologies. It's one of these T's that Jerry mentioned, and they all come together right now. And I would submit that we can learn a lot from the cerebral cortex design, if you like. And I would like to invite you all to do some reading here by Herculano Husel. And you can sort of start to unlock the brain's mysteries, puree it. New York Times article from December 2017. When I read that article first, then I spent the rest of Christmas break just reading her books, and were very inspiring for me. So digital twins are not new. You can combine and compare information. You can start to find patterns and make predictions. That's what the cerebral cortex does by observing what's going on underneath, if you like. It liberates us from the present. It gives us the ability to look at yourself and think, this is what I'm doing, but could I be doing something different? That's the kind of ability that this additional level or hierarchy of additional levels above the cerebellum provides us. So what can we learn from this amazing digital design? Well, first of all, adaptive control. Several people already talked about that in one form or another. The idea is to redesign the controller at runtime. So if you have this additional level or several levels above it, then you can observe what's going on underneath. You can see whether the controller actually does its job. And you need a model for that to understand what's going on. And you can observe what's going on in the plant or the system you're observing. And then you can make adjustment. You can redesign the controller. You can change the controller at runtime, what we call software engineering at runtime. And here are some of these desirable properties that you would like to see in a digital twin. Adaptivity was just mentioned in the previous talk. Autonomicity, or autonomy to a certain extent, but autonomicity is a better term. Cooperation, you will have lots of competing goals, if you like. And all of this changes over time, so you need support for evolution. So how do we get from here to there? What do we need at the cerebral cortex level, if you like? You need models at runtime. We need to continuously model what is going on around us, grab context, find patterns, synthesize information, and allow for plenty of uncertainty. I think business process model demonstrate that really beautifully. And then adaptive control is, what am I currently doing? Can I make predictions what is going to happen? Do I have to do something different? How do I optimize goals, if you like, and perform trade-off analyses? When is it time to just optimize for performance, and when is it time to just survive, if you like? So we have to adapt models and we have to adapt controllers, and to a certain extent, we all did adaptive control extensively over the past year in this pandemic. These layered architectures are not new. They started in the 70s in AI, and IBM did a fantastic job around 2003, 2005 with a Smarter Planet and the autonomic computing initiative. And we were right smack in it. We had several projects with IBM on this. And this is the autonomic computing reference architecture. At the bottom, you have sort of autonomic elements that immediately react to things, automatism, if you like. At the next higher level, you have you optimize for goals, specific goals, like performance, minimize power consumption, optimize resiliency, if you like. These are different and very goals that compete with each other. And at the very top, you have Jerry Como's Watson orchestrator to a certain extent, maybe fully automatic, maybe just a person who makes the decisions, trade-off analysis, if you like. And at these three levels, you have different policies, and these policies can also be affected by the higher levels, if you like. That's the ACRA or autonomic computing reference architectures. In my mind, this is still the best architecture for many of the systems we design. And it is a viable and truly excellent architecture for the digital twins to provide these desirable properties. Over the last couple of years, we tried to come up with a digital twin evolution model and the maturity model in particular. And these three stages on the left-hand side, they have been around for a long time, basically coming up with a beautiful model and then realizing a real twin, if you like, in aircraft design or almost any design. That's very common. But now, with all these technologies around us, from IoT, with a lot of increased sensing, if you like, and without clouds, we can't do that. Compute and storage clouds, it's very important. And to do this in real time with network control, pervasive sensing and actuating is absolutely critical. But now, some of these latest technologies like machine learning, AI ops, DevOps, mentioned several times, and going left, right, shift left, shift right, if you like, we have superb opportunities for automation and influencing intelligent cyber-physical systems. And two of these really important properties are autonomicity and cooperation. And that's what we propose as stage 4, stage 5. So if we get to these stages, then we are really making progress, if you like, with respect to digital twins. The key enablers here are at the bottom, but let's leave that. The slides are also in the space you have access to. So software-intensive digital twin systems, that's what we are after. They must orchestrate the runtime adaptation and the evolution mechanism. Then you can basically aim for some of these really ambitious goals we heard over the past hour, if you like. That is a good platform for achieving some of these things. To do runtime evolution and runtime adaptation, you need some kind of software engineering at runtime. And that's basically what we are concentrating on these days. So the vision is to, with these kind of capabilities and with digital twin technology we just described, is to augment human and machine capabilities with intelligent digital twin capabilities. And the realization is amazing because CPS are everywhere. They affect virtually every engineered system, if you like. So given all these amazing technologies, can we provide cognitive support, if you like, to what we started out with, to our brains, if you like? So two case studies we're working on is personalized healthcare and smart urban transit systems, but also others. But I just would like to concentrate on the left one. And health digital twins are very hot. Siemens, IBM, and several other companies are working heavily on lifelong personalized physiological models. that are updated with each fitness record, scans or exams and findings, gathering all this data over very long periods of time. And that can possibly help certain health conditions. For example, MCI, mild cognitive impairment. I'm very passionate about that because my dad had that and eventually severe dementia and passed away a few years ago. And if it can make a difference, just to quote Jerry Como, I think it's time to create an Apollo program for health digital twins. And cognitive support for MCI is as good a start as any. And I'm sure other people are working on that. So you're not the first ones to come up with that. Everywhere this is being done, and just health digital twins, for example, the Siemens digital twin for the heart is amazing. So getting into this, I think we can make a real difference. But it's one thing to do things in sort of near real time. It's another thing to do this over 30 years to collect this data for helping, providing cognitive support with respect to help with mild cognitive impairment, MCI. So just a few take-home messages here. Some of the desirable core properties for AI and of the automation. These are core digital twin properties: adaptivity, autonomicity, cooperation, and evolution, because you have digital twins that have to cooperate with each other, and then you get better automation to a certain extent. Augment software capabilities. We just talked about digital twins, either coming from perfect digital twin, a piece of hardware or a human, and then trying to come up with a copy of that, if you like, in software. That's one direction. Another direction is to start with a model. That's kind of the old way, and then an aircraft model and come up with an aircraft, but also on the software side. For example, if you want to monitor clouds, cloud operations, you need a digital twin of software, of the cloud that is being deployed. You need a digital twin of that so you can explore things, make predictions, and so on. So digital twins of software is also a very hot research topic. And then augmenting human capabilities, health digital twins we talked about, and augment CPS capabilities, cyber physical systems, for example, smart cities, smart supply chains, and so on. And the final sort of take-home message, I kindly invite you to check out some of the writings, books by Susanna Herculano Uzel. It will change your way how you think about these things. Thank you very much. And I would like to thank my entire team, lots of PhD students and professors and collaborators, and particularly IBM collaborators for supporting us over the years and working with us. Thank you.
Thank you so much, Hazi. I look forward to returning to these ideas as we get going. So now I'm going to do a little bit of a switch.
I think Sean was able to rejoin. So we're going to.
I've just rejoined. I have a locked laptop at the moment, so I'm now on my iPad. The AI locked me out. I'm not a very good technical guy sometimes. So what I'm going to do is I'm going to share the screen, share content, share the screen, and start broadcast. And then I'm going to open the slides up because I now have all the slides available. Sorry about that, everyone. That was not quite what I was after.
We see your first slide, Sean.
You can see my first slides. Well, the technology does work sometimes. I want to talk about where I think some of the digital twins are coming from and where they're going to. I have a picture here and it fits neatly, I think, with some of the stuff I've seen earlier in the earlier session, because we have people, we have machines working together with some of the AI helpers I've got here, and I've got 3 little helpers here. So what do I want to talk about? I want to talk about twins, digital twins and complex systems, because I think in complex systems, things become too much for me on my own, and I really need some other way to help. And I think this is where the digital twin approach helps. I think the digital twin helps us to make decisions and then act. And that's really where I'm going from. That kind of draws with some of the discussions that we've had earlier. Digital twins have to support different perspectives, different outlooks on life. And that doesn't matter whether it's operational, strategic, tactical, or maybe it's somebody in finance and somebody in technology, or somebody in the business area, somebody in sales. And I think that's really important. And then I want to drop into digital twin and design, because I think that is important. I think because we have complicated systems, it becomes even more important. And I want to emphasize, it's not a technical thing. This is not about cool coding. We can do that and we can use some of these tools, but how do we use these tools and why do we use these tools? I think is important. Once we get to the end, then we'll see where we think they're going to go in the future. Digital twins is kind of a dream and not a dream all at the same time. Oliver, my PhD student at the moment working on this with me, he goes, it's just hype. And then I point out, hey, what about Google Maps? Google Maps to me is a great example of a digital twin application. It's doing something that I'm not anymore very good at. It tells me how to get there, but it also guides me through decision making. And it fits into this picture I have from Microsoft showing the smart city. Google Maps is a very simple and a very tangible example of a digital twin to me. It supports my decision making. It tells me what it asks me. How do you want to get? Where do you want to go? It starts with, where are you starting from? It says mein Standort there, so it's where I'm starting from, my starting point. What am I doing? How am I getting there? Do I want to walk? Do I want to take the train? Do I want to drive? No, I don't want to drive. I want to take the train. Then what's the best way? I could use something like the SBB app, which is the train app here. But actually Google Maps tends to take that human side a little bit more gently, and it shows me through the process. Then we move to the smart city, and it's like, wow, that's a big city. Now, how do we interoperate all of these? That's quite difficult. Where do we start from? Do we start from one thing, or do we have the big vision? I like the Apollo thing. I want to put man on the moon by the end of the decade. But actually, we're going to do lots of little bits and pieces on the way. We're going to test the engines, which of course blew up quite a lot. So we're going to get some things wrong. But actually, what we've been showing is that we can show these little pieces joining together. And that's where ontology can help us match them together and actually mash them up. So we can actually get flows so that we have some consistency. Because a lot of this, you know, is, as we saw, unstructured. Parts of this vision exist, parts of it are just a pipe dream at the moment. This is my view in an industrial world. I work most of my time in industrial worlds, and I see advice is demanded by many actors in many different situations and along the life cycle. I'm kind of fed up with designers just talking about it. Oh, we need this information from the operator, from the user, they usually say. They need to give us that. I'm not going to give you that. Why should I give you that? This is an example of an aero engine manufacturer. They have a design cloud, so they have as built, as designed, as commissioned, as operated, as maintained, as abused, as remaintained. And we have other parts in there as well. It's a very complicated world that we live in. And we have many, many actors in here. And interestingly, we have many data flows. And I saw that earlier. I kind of chuckled at one point. We have lots of different applications. We have lots of different places where this is coming from. Digital twin, when we begin to get those processes into it, physical processes as well as business flow processes, and when we begin to integrate the people, we know where the data is being produced, we know what we're trying to do with it, and we know who's trying to consume it. And often the person who's trying to consume the information from it is not the person that produced it. And actually, they might as well be speaking Martian and Venetian to each other. Value is only created when decisions are made and action taken. And people generally take the action. So I want to go through this, walk this through. What would happen if we could do this? So I'm looking forward. If you do this, this happens. If you do this, this happens. Goes back to actually the Google Maps version of digital twins. I think it works very well. It tells me if I go this route, it takes me this much longer and it uses this much more fuel. So those, I think, are quite interesting. We already have the fundamental approach to that. And I think it comes from business science. And we're trying to overlay service science on top of this. Service dominant logic helps me understand, I think, what's going on, because the value comes out of the action, not the product. So I really think that some of the service dominant logic approaches are really need to be embedded in here. And to be perfectly honest, that's actually quite hard. We saw that earlier. Where do I start? How do I start? How do I start? I've been using Porter and Hepperman's approach. I think they're really well suited to control and optimization digital twins. Autonomy, Arnie Schwarzenegger kind of scares me, actually. I don't want the machines running the shop. I want me doing that. So maybe there's some delegated authority that I give them in terms of the autonomy within a bubble. I really want them to do some optimization, and I kind of want them to be a co-worker as well. Hey, Sean, if you do this, this could happen. If you do this, this might happen. And I think those two different levels fit neatly with one of the presentations we saw earlier. I think the digital twin can also be a teacher. We've just finished a project where we actually had a tunnel, and one of the outcomes of it was an operator's simulator, kind of like in Star Trek. And I saw this when Captain Kirk actually broke the simulator so he could win, because you weren't meant to win. But I can see that gaming type simulator to actually train the operator for events which are critical, which will never, ever, or what maybe once in their operational life happen. And to be perfectly honest, a lot of the younger guys coming through are very much used to using things like Minecraft. And the switch between the real world and the cyber world for them is less clear, I think, to some of us than some of us. Different decision-making scenarios. Operational, I need a decision now. Tactical, well, by the end of the week will do. Or actually by the end of the day. Strategic, months or years. I think the digital twin here needs to help us. We need to be able to plan scenarios, in effect. I need to be able to play the 3D or multi-dimensional chess game. This is why I come back to difficult, complicated systems. Got many actors in here. We got many people. Some are very technical, some are very business orientated. Trying to bring them together onto a common playing field, I think, is really what the digital twin needs to be able to do. And I think that's something where we're going to go. What makes this twin smart? It's not the coding. I'm going to be really blunt there. Coding isn't what makes it smart. The twin should be kind of a real mapping of components with the physical and the virtual, with data flows together. That's, to me, the foundation. If I don't have that, I'm kind of lost. It can be orphaned a little bit and come back again. Whether it has to be up to the millisecond data within the digital twin, I'm not convinced. It depends on your decision-making horizons. But looking at service dominant logic, we broke this down into service ecosystem, service platform, and value co-creation, and some key characteristics based on that. Just because something does something exceptionally well and it can't connect with anything else doesn't make it stupid, doesn't make it dumb, just doesn't make it smart. And I think those connections, we need to explore how to connect them. One of the key things here that you're seeing is that it's linking up different actors, different people. This shows to me that the digital twin is a key aspect in supporting value co-creation between many actors within an ecosystem. value co-creation for the beneficiary. And I'm going to come back to kind of geeky service science language there, because I think it's absolutely key there. Because the twin has to help us find the right data. I don't want huge amounts of massive data, it's just a cost. It has to give it to me, the information, it has to transform it into information so a group of people can take an action. And that's really part of the data to information, knowledge, wisdom pyramid. I've done it as a downward trickle because I think a downward trickle is really what's happening. Some of this has interactive design. Some of this is really data science stuff. But getting it into knowledge and wisdom really needs people talking and internalizing it within the firm and looking back and reflecting on their decisions that they've made. So what have we been doing when we've been developing digital twins? Spend more time on the problem space, understand the problem, understand how the people, the machines and the processes within the ecosystem all interact. And I will use the word ecosystem because I think a firm is not just one person, it's not just one blob, it's actually full of people like me. We don't follow the instructions. Well, you should have read the process, you should have read the protocol. People don't. Technology here underpins and enables the service delivery. So I've gone through understand, ideate, prototype, test, and repeat, even to the extent where the problem explanation here is really important in terms of being able to understand the space that you're operating in from different perspectives. So in a very short period of time, what we've done is we've seen what twins can do. We've got a paper now with 10 different cases just published in it, looking at different across the life cycle, looking at different actors, looking at different situations. And I'm comfortable that it can do a lot of things there for us. The twin to me provides delegated control and advisory, and training fits into that as well. And I think it's we're making the person more powerful rather than less powerful. We did some work where this really came from, where we were looking at taking away jobs that the operators didn't like to do. It was a call center and they didn't like certain jobs. So we actually found a better way for them. It was done through automation. It's got to support multi-actor decision-making and knowledge building. If it doesn't, it's completely useless. And to do that, we need to learn and understand people, processes, and things more. They're complicated in complex systems, but it's more than just coding. This is just an outcome from the project, just really to remind you that it's data, information, knowledge, really to understand and then why. Things right and doing the right things in the future. It's got to link across and different actors within the life cycle. And we have a mess of life cycles, to be honest. If you look at a smart city, we really have a mess of life cycles. We have old assets and new assets. Look at power generation, that's stuff that's less than a year old and stuff on the grid, which is 40, 50 years old. And it's got to link the different layers that we have, which is technical, which is business, which is high level business, business to business. And that's actually what makes it quite challenging, I think, for people, because there's a lot of things in here to consider. So at that, and apologies, I'm not on my laptop, so my iPad just fell over. Thank you very much for your time. If you want the data to action framework, where a lot of this approaches came from, you can just scan the QR code and take it. And I look forward to the discussion. Thank you very much.
Thank you, Sean. Well done on coming back in, and I'll look forward to as we circle back.
Thank you very much. I'm really sorry for that. I've got a black screen here with a little symbol of a lock on it, and it's kind of terrifying me at the moment.
Oh,
thank
you. Yeah, we don't envy you that. So our next panelist is Dr. Robert Cohen. He's a senior fellow at the Economic Strategy Institute, where he focuses on cloud services, artificial intelligence, and the Internet of Things on the US economy and on jobs. So I'm very much looking forward to this. I'll stop sharing now so Bob can come in. all yours.
I have host disabled participant screen sharing.
Oh, sorry, Bob.
It's all right.
I dropped it somewhere.
Still not.
To it. Just 1 second.
Okay.
There you go, Bob.
Okay. Thank you. Okay.
Sure.
All right. So my presentation is a little bit more specific in terms of how automation is actually used by companies. I've been focusing on kind of the microeconomics of how firms are evolving from cloud computing and grid computing to being smart companies where they're implementing a lot of AI models using machine learning very ubiquitously and employing digital twins. And I start with a number of cases. I cite what I think is the biggest automation success and why it's interesting. Then I look at the biggest failure, why did it fail? And then I look at some other interesting technologies that'll probably shape the use of AI in the manufacturing sector for the next years. So the major success, just a second here. I can't seem to close this box. There we go. Okay, so the major success that I've seen is Volkswagen's efforts to create an industrial cloud, linking all of its operations. And the success measure is that Volkswagen intends to see a 30% increase in productivity from 2016 to 2025. I mean, that means probably something like a 5 to 6% average. The US economy's been growing at roughly 2% for the last 30 years or so, with a few exceptions. The VW Industrial Cloud is essentially a platform that includes information about production and the line processes that moves across factories. And it includes many things like the models that are used to run different processes, the digital twins, the operational management software, et cetera. And part of what the cloud depends upon is VW's digital production platform that describes all of the plant floor operations. So one of the additional points of success is that VW in the last few years, not so much by implementing AI in plants, but by making, by focusing on optimizing processes, has been able to achieve roughly a 7% gain in productivity. So they're a little bit ahead of where they're trying to be. So why is this successful? Part of it's because the industrial cloud acts as an open platform for developers, so that not only traditional developers within VW itself, but also in competitor companies and supplier companies and in independent companies that are interested in supplying software to the industry and developing it. So this is kind of a broad, not only company, but industry platform. And VW is partnered with AWS for analyzing the factory floor and for Siemens for integrating all the production machines. And the suppliers can contribute software for things like managing automated vehicles. There's also a great focus on scaling this whole system globally. And VW is spending 14 billion euros to 2023 on digitization and mobile services in addition to 30 billion euros for e-mobility. So this is probably one of the more impressive efforts that I've seen in the manufacturing sector. There are some challenges though. When VW produced its first 10,000 electric cars, they were put in storage because the software didn't work. The basic architecture was developed too quickly. It had 8 different electric architectures. The software systems didn't understand each other, and things malfunctioned or were unable to function. And a real question is whether these basic software systems can be effectively integrated. One of the comments on this whole challenge is that VW is selling the model that was put in storage, so they were able to remotely upgrade all of the software, at least in enough of the cars to get them in the marketplace. And I know they're being marketed in the US. The example of the failure is that Adidas tried to do something where they not only put new types of production equipment in their plants, but also effectively use modeling. So they were able to figure out what's the best way to produce a sole of a shoe or the inner liner of the shoe if you're running in London or Paris or San Francisco. And so they could, so they set up 2 speed factories, as they were called, that were focused on consumer selected production of non-leather shoes. So you could go online, select the top covering, select the bottom of the shoe for where you wanted to run, and select the liner in terms of how supportive it needed to be. The value issues were the main stumbling block, because while they were very interesting technologically, they were only able to produce about 1 million shoes each in 2017. And Adidas sells 50 million shoes, 75% of which have leather tops, which could not be produced at the Speed Factory. So nevertheless, the Speed Factory demonstrated that it could produce shoes 50 times faster than the regular ones. And some of these technologies, even though the 2 factories were closed, have been implemented in other plants that Adidas has. There are a couple of other dimensions I wanted to focus on. One is changing cultural dimensions and how AI has made that possible. Mercedes has created a thing called intelligent workstations in their newest plant, which not only is a smart factory, but also has in one large part of it significant 5G private networks, so that not only are the parts and vehicles roaming around managed by a wireless network, but all of the workers are too. And you can get access to AGVs, you can see digital twins, etc. And workers at these workstations are essentially a different kind of digital blue collar employee. And they're very facile at using virtual reality. They can manage machines, manage the location of components and parts that they need to install. And this defines a way to use AI that several people have mentioned before to enrich work, that traditional workers become skilled in working with data and software in addition to assembling a product. One other impressive case that I've seen is at Siemens in Hamburg, Germany, where they make PCBs, where they essentially do what I'm calling flip a switch manufacturing. Because they can use 5G private networks, they're untethering all of the machines that they use, and they can essentially reconstitute the machines by flipping a switch because all of the information needed to go from one PCB to another has been optimized. And once you flip the switch, a whole different model is in place and management software, et cetera. So you can jump from one product to another. And this, I believe, defines a new way for AI to impact manufacturing. Firms need to have a deep understanding of how products are produced and the processes that are involved, and they can improve productivity based on the ability to switch production rapidly. So I've basically stuck to a lot of individual cases here. What I'd like to wrap up with is I'm looking at kind of a holistic ecosystem based on the VW efforts, where they've actually said their goal is by 2025 or a little bit later to have all of their 130 factories, including those from the different parts of VW, like Porsche and its suppliers and Rolls-Royce, et cetera, to be interconnected and easily able to shift all sorts of knowledge using 5G slices in a commercial network, whether it's a hyperscaler like AWS or Google, or it's a series of phone companies. They want, what the goal of this is to not only improve productivity, but to do that by eliminating disruptions in production. So if one plant in China is very experienced at producing electric vehicles, and a plant in Germany runs into a problem that's likely to be disruptive, they can use a 5G slice to send not only, a digital twin, but all sorts of other knowledge that's been put together to optimize the production of electric vehicles, so that the plant, say it's in Germany, can take this information, go through it very quickly, figure out how to solve the problem, and essentially take advantage of what I would call, what an economist would call, network effects. And I think that these network effects of interconnecting the plants have really not been incorporated in Volkswagen's projection of a 30% productivity gain, because they're extremely hard to measure. And I really haven't seen any economists try to measure this in kind of a 5G smart factory system. That's one of the things I'm trying to work towards. But I mean, I think this suggests that the ability to achieve larger productivity gains, I mean, I've seen in other isolated plants, like being run by Ericsson or Siemens, some of those plants are seeing a 25 to 30% productivity gain in 1 year, because they untether their equipment and they can control processes much better. So that this links back to the first group of presentations on analyzing business processes, because that's really the crux to taking advantage of these network effects. So I really thank Jim for inviting me, and I love the previous sessions. I think this is a very productive seminar.
Thank you. Thank you so much, Bob. And I see Jim is clapping there. I look forward to coming back to your comments. The fine-grained nature, I think, was especially helpful. And whoops, I almost left the meeting instead of sharing the screen. Let me get that going. So our final panelist in this session is Erin Bishop-Rapaki. She's an expert in high-value applications for robotics, and some of her product and business development work is focused on telepresence robots, indoor mobile robots, and robotic picking in warehouses. And she's now sharing her expertise with her portfolio companies as an investor and advisor. So Erin, thank you so much.
Thank you. Nice to be here today. Can you hear me and can you see my screen?
All good. Yeah.
Well practiced. My time working on telepresence robots, I was debugging video chats 5 years ago from folks. Good morning, good afternoon. Yes, my name is Erin Bishop or Packy. And for anyone who takes a look at my LinkedIn, I've been doing a number of different robotics startups for the past 10 years in Silicon Valley, starting with core academic theses and then quickly moving into robotics, logistics, and warehouse automation because that was the next technical domain that was ready to automate. And when I say next, this was the conversation in 2010 and 2011 when Amazon bought Kiva Systems, and that somewhat created a rush towards looking more at warehouse automation. Fast forward 10 years, and there are many changes that have occurred that are forcing that need. Just to reiterate on my abstract, I think when fielding robotic systems, especially advanced technology, many people are familiar with robotics from the perspective of they've been inside automotive manufacturing for decades, they've been doing welding cells. That's a very fixed work cell where a robot has to go from this point and can be directly programmed to go to this point. And so it's directly programming inverse kinematic solutions. It's directly deciding your point space. And the robot can do that one point very well, but the robot's not making any decisions. It's also not grasping. And I start with this because when you add grasping to a robot for a product, robots can grasp a product that's always in the same location, but robotics are still challenged in bin picking, for example. You have a bin of loose parts. They're all at different orientations, and maybe they're not six-sided. You're not uniform for six-sided. The robot has to figure out which side to pick, how to orient it, and then put it in. Well, then the robot actually needs a lot more intelligence to make that decision. And I'm making this distinction now because that is where robotics is stuck. You're seeing 2D flexibility and you're just starting to see 3D flexibility. I say 2D as like a packaging company, like picking up cookies off a conveyor belt. Same shape, predictable image recognition. The X, Y position of the cookie on the conveyor belt is the only variable. Robots can do that, and they are doing that for cookies and basically uniform goods. It is increasingly becoming capable to do that for meat. Meat are different shapes. They're shiny, so it has ocular distortion to the computer vision, has like shiny distortion. So again, choosing the grasp object, the grasp position for irregular shapes is something where robotics is getting to. And the reason why I premise this is where people are advancing robotics, it's important to view your robotic system as somewhat like training an apprentice, training a very expensive apprentice, because the robot, in order to get better at its job, needs to practice doing its job. And that's just another word for training data for 3D manipulation. And that's the line to really think about when thinking about where robotics is and where it can go. So again, a number of challenges. Factories that have legacy systems, maybe legacy automation that's not well wired up. Warehouses, there's a funny thing. Robotic forklifts don't know where the manual forklifts are. That is a huge issue because the robotic forklifts and AGVs are operating on a fleet manager, and that fleet manager is routing and navigating, but the manual forklifts are invisible. So companies will have to decide to put sensors on manual forklifts so that manual forklift can communicate its interior position to the robot forklifts so they don't crash into each other. And robotic and forklifts, the value proposition is in its speed. And the reason why robotics is hard is because safety. Robotic forklifts are somewhat stuck because although a manual operator will speed and will crash into things sometimes, No one's comfortable with a robotic forklift speeding and crashing into things sometimes. So the safety systems to operate faster, in which case the vision systems, the collision systems all had to operate faster. And the main thing, the main issue with robotic forklifts is actually safety rated sensors. Current safety rated light bumpers on forklifts and AGVs are only rated to like maybe 3, 5, 10 meters at most. The sensors being created for self-driving cars are not yet safety rated to the functional safety needed for forklifts, but forklifts can't drive faster until they can see further with a safety rated light bumper. Office parks, bystanders, like, you know, the Bossa Nova robots doing inventory inside grocery stores. It's easier to do it when the store is closed, but Savioki has a number of, they did a number of trials in what happens when a child jumps in front of the robot or kicks the robot. What happens if a dog is at the baseboard? So the bystander behavior is very erratic. They will antagonize the robot. In outdoor areas, this is the issue with self-driving cars. Roadside delivery robots are a little bit simpler, but there's an infinite opportunity for obstructions and robots to crash into things. This is a little bit why warehouses are simpler right now, because a warehouse is a constrained environment. It's a workspace with rules and some predictability, but consumer-based automotive and last mile delivery robots and curbs and different colors. Oh man, it's, you know, there's, I'll put it this way. The self-driving car companies, actually this talks about simulation and digital twin. Every self-driving car company has built their own simulation and video game engine. And what they're trying to do with these simulations and the on-road data is better predict all these outlying types of crash scenarios. So next steps, also the Wi-Fi and 5G problem. It's solved in some domains. It is being used, but for those inventory robots inside Walmarts or some robots inside warehouses, the racking, all of the metal is interference. And you actually can't get enough bandwidth for doing real-time AI. So the decision-making capacity is somewhat delayed. You need onboard decision-making, which is edge AI, which some systems are doing, but you're trying to send as little information over the network as possible because it can't handle that bandwidth, or there's interference from the products in the space. Security is a huge concern. A number of conversations about whether or not medical robotics, like robots moving medical goods around a hospital, will it be stolen physically in the real, or will it be hacked? This is where networks need to help. Robots having dedicated networks for this reason is very important. High quality networks. Fleet manager interoperability is starting to happen, mentioning manual forklifts with robotic forklifts in the same space. And something to make this successful is a bot work zone or dedicated work times. There are a number of cleaning robots coming out. They should be working at 2 a.m., not with people around. So next slide, let me just go here. So maintenance. The issue with robotics right now is where people want to deploy robots, there's usually not a lot of robotic technicians in the vicinity. The way it happens currently for manufacturing sites is the manufacturer hires robot techs, or they're working with a local integrator and someone has to get on an airplane to fix the thing. A lot of the people buying collaborative robots, it's easy to program, but it's still not that easy to program. And they're trying to get up to speed with programming it or changing it over every few months. The next steps is actually remote technical support. And teleoperation, these companies are the ones talking about it rather loudly. Phantom Auto is doing vehicles where they can have a forklift driver or a driver elsewhere log in to handle an exception. So a self-driving car, robots fail. And a self-driving car or this robotic yard, like it moves semi-truck trailers around a yard management, there will be a time when it gets stuck or a time when it gets confused. And in order to support these self-driving systems, you need to be able to have somebody log in to correct the problem. Plus One Robotics is doing this with the robotic arms, manipulators. They've been quite vocal about this. And Olus Robotics is setting up a system for anyone who buys a universal robot will be able to get remote technical support for changeover and for downtime. Integration. Now, I'm going to do a shout out to Omron. They bought Adept, and I used to be the product manager for the Adept mobile robot back in 2011. It's when you have a factory, there are car companies who do have the resources to make sure every machine is talking to every other machines to have a master database. But there's a lot of manufacturers who either don't have the internal IT department, don't have the experts to really get inside every manufacturing piece of equipment and have them talk to each other. And so there's a long tail of companies that either don't have that expertise or their machines won't communicate either. So using external sensors, having a fleet manager connect to a proximity sensor and say, okay, there's now an object on the outside machine feed that will tell the robot to come. And this can be done with 3D cameras as well. LiDAR, getting more information from those cameras speaks to the fleet manager. And the fleet manager is a digital twin. We spoke about Google Maps and navigation. Fleet managers for mobile robots is the Google Maps of inside the factory or inside the warehouse. That's exactly what it's doing. It's telling the robots how to route, where to go, who picks up what and when. And in essence, these fleet managers are a digital twin. So in order to train these robots to be better, these robot companies are still making the robots better. They field it, they do a 4-month pilot, maybe it didn't work so well, maybe they found a less expensive camera, maybe they want to rather do their perception system this way or something got obsoleted, maybe their controls are saying it's not fast enough. What they have to do is retrain the picking. There was a blog that came out from Google 5 years ago, their Arm Farm, where they had a few hundred robots just picking up and dropping objects. What they're doing is they're training the algorithms, the grasping algorithms for how to pick up different types of objects, adversarial or not. But every time, if a new customer comes in and says, my object is this color or this large, or this is my workspace, they're going to have to change the cameras that they use, even for their own internal R&D. So 3D machine learning, we all know what 2D image machine learning is, cat versus dog, muffin versus chihuahua. We know what that is in the internet 2D image space. In robotics, it's far more complicated, and where research is going is actually towards, there's a formal word, spatial AI. Spatial AI is using 3D data from 3D cameras. And the benefit of 3D is you don't have the ambiguity of color and shadows. You have a little bit more factualness from 3D data of what that object is in space, where it is in space, and what it's doing. So most of the robotics community is learned that self-driving car companies are hiring game developers like Unity, Unreal, video game developers to simulate 3D environments and then train the robots in those 3D environments. And I've been enjoying being part of this conversation because I have a client who does a lot of work in Unity for various robotic forklift startups. And what they're doing is they're simulating the perception stack to the point where they're actually simulating the noise and distortion from a LiDAR, from a 3D camera outdoors, maybe to see a plant, to kill it with weed killer. And the next steps here, and this is really where robotics is the robotics research community is gonna focus, is this spatial AI sim to real. What is the quality of the training data from a simulation? If you have 1 million training points in the real, plus 1 million training points of simulation, does that make it more robust? Are the training points of simulation, does that even work at all? And where you can augment models using real plus sim data, we all kind of know like just sim data is still complicated. However, Ambi Robotics, they're the Berkeley Ken Goldberg group. They invented DexNet. They just launched a podcast. They're training in simulation. They're doing robotic manipulation and bin picking for small sort envelopes, small boxes, packages. However, warehouse bin picking is still the holy grail that hasn't been figured out yet technically, because it's such a large object mix that requires such different types of grasp of manipulation type skills. So licenses, this is where I get a little personal about robotics. I see so many talented small companies in robotics. And I wish they would just consolidate, because this is a hard problem that I see a company that's great at mechanical, not software, a company that's good at like software, not mechanical, not hardware, not electrical. And a lot of these companies are using these tools, especially with ROS and these different packages. Good idea. Consolidate licenses. And ROS is a community robot operating system, open source robotics. However, if a company comes to me and tell me they're just using ROS, I know ROS is not good enough standalone. Every company needs to be developing a core piece of technology, whether it's that simulation and manipulation environment. Maybe it's a new sensor. Maybe it's a new type of grasping. They usually need some new technology in order. If I'm evaluating a startup, I'm looking to see if they have a new technology to differentiate them, and they can leverage these licenses and APIs at the further down the stack. And there are good companies who are developing these tools. Bluebotics, any AGV company can buy their controller and have a SLAM-based AGV. SLAMcore is doing something very similar. A lot of people use their SLAM kit. Real-time robotics is very interesting. They're partnered with Siemens. One of the issues with pick rate for robotic manipulators is that they can't do real-time collision control when in close proximity. Now, if you have two robots doing the same thing, that's fine. They're not going to crash into each other. If you have two robots in proximity who are doing real-time manipulation and grasping, there's a chance there could be a collision. And real-time robotics is actually selling a chip that helps with real-time collision models in order to have multiple end effectors work in the same workspace, which gives companies the cycle time and the pick rate that they actually need. Culture. I think this was touched upon before. The robotics companies are being successful training people to how to use the robots. The people are getting upskilled. Very few, if not any, people are laid off because the robot is installed. A labor shortage is far more the issue. And I heard an endearing talk, like one of my friends doing a farming robotics company brought their kid over and asked a lot of questions. Like, I'm a farmer, my kid might be a farmer in the future, but my kid's gonna need to know how to use these machines and these robots. And that's not too far off from what all of industrialization of farming was. So the next steps, educate employees on how to use the technology, how to be more efficient. I'm a big advocate for a world of work where people do not have to injure themselves. So the world of work in the future will be people project managing and supervising and operating robots as tools, because robots are tools. They're not going to take over. I'm very realistic about robotics. A lot of them just don't work well yet. 1 minute, no problem. This gets to my, value. There's a lot of companies, especially these smaller manufacturers, who don't really understand their processes all that well. They haven't really time studied them. And there is a statistic that the addition of mobile robots, the value actually comes from changing the process around the factory, because they're now thinking through their entire system. And they're not just optimizing the one material handling move that a robot does, they're optimizing their entire flow when they really get their head wrapped around this. Using sensors to do time studies is a really great way to start simulating your own environment and creating a rudimentary digital twin of the manufacturing environment. And I'm an industrial engineer. There's a book called The Goal. It's an older book. Many people have read it, but it's a good book for looking for bottlenecks. So why now? This is just the part I want to hammer on. Globalization is changing. I don't think it's going to be called globalization anymore. It's just the economy. What robotics steal jobs numbers fail to understand or fail to mention is the increased market demand for all goods and services. And if there's 1 million people who want to buy avocados and 100 people that can make farm avocados for that million, and then it goes to 100 million, you don't just 100x your labor pool. You cannot linearly scale your labor for the increased market demand. And the economy is doing well. There's a lot more demand for goods and services. And there's labor shortage, not only due to just more demand, but demographic inversion. There's a lot of retirees. And we really got to think about how much we're going to be shipping these items around the planet. CO2 emissions and And COVID did challenge lean supply chain and whether or not it was a good idea. So the future I foresee is with robotics, we're going to de-shore or home shore manufacturing, so all manufacturing can occur near their target markets. And the things that we need to be aware of politically is how we're going to tax automation. And my hope for the future of humans is that every human has the opportunity to find their purpose and is properly educated. Right, I don't think jobs is a good economic metric. However, right now we need to make sure there's a certain part of the human population working in order to support the goods and services for the entire population. So, and creating economies where, you know, maybe robots steal a manufacturing job, but how do we make sure we value that people can be mothers and parents and teachers and volunteers, and also be economically supported for that? So I think that's where I'm ending my talk.
Thank you so much. I'm going to see, let's see, can you end your share and we'll be able to see everybody who's with us.
How do I end the share?
Little red button down on the bottom, I believe. I don't have a digital twin, so I'm having to do it from memory.
Actually, I think maybe your other computer, maybe if you've got two going, Aaron.
No, I'm on my main computer. Let me just open up Zoom a little more. Where I think if you no longer make me a host, I'm really sorry. This is
No
I
worries.
closed my PowerPoint.
Yeah, there we go. And Jim, I'd like to do a time check. What's our plan?
Well, originally, I think we're about 10 minutes behind schedule. So why don't you do 15 minutes? Let's start 15 minutes of Q&A, and Ralph and I can go pretty quickly at the end. So I think we're going to run over by 15 minutes.
All right. Well, thanks for that reality part, and I'll let you keep time on me. All four panelists have such deep expertise, yes, and huge rounds of applause here, and specific expertise, which is something that I think has been lacking. And so kudos to the organizers for selecting people who could take us down a deeper road than so many of the webinars I've been seeing recently. But I want to leverage that deep expertise. And I don't know if this was specific to the issue of digital twins, but in each of the talks, and possibly most explicitly in Aaron and Sean's, I heard the importance of perspective taking. And that's something I would like to kind of, touch on across each of the four. And I'll also be watching the chat for audience questions about this. But if I look at Housie first, and I know you were getting a shout out, especially around the use of personal digital twins, right? The medical application. What kind of perspective shift do we all, have to make to then use that digital twin effectively? And the challenge I was seeing in that was, even when 23andMe came out with data that we could certainly incorporate into that medical digital twin, they had to help and educate people around how to use this information that you've never had before. And from your own experience, could you share where you've seen that perspective change effectively and any pitfalls we might all want to avoid?
Well, thank you very much for that question. We both live in British Columbia, and over the past year, interacting with doctors has changed dramatically. So any prescriptions I got over the past year, I got over the internet by talking to a doctor online over a TELUS network, the phone company network that was established by the phone company. It's quite amazing. And people have changed their attitudes dramatically. I think Jerry Como already mentioned that earlier. So right now is the time to actually do that. Over the past 30 years, people have tried time and again to come up with medical records and put them on credit cards and things like that. And basically hasn't quite worked, right? And digitizing what is in a doctor's office, they have digitized it for themselves, but it's still not shared uniformly. But now is the time, given the experience over the past year and a half, if you like. Things have changed dramatically. People are way more willing to actually engage and do this. And secondly, we have the technology at our fingertips right now to actually do it. Starting with cloud services, that is key. And secondly, to be able to the mobile platforms we have, and that's what is required, for example, to talk to doctors in British Columbia, Canada. We have the technology in place, and now we simply have to do it and execute it. And context is absolutely key. You can only do that for a certain domain, if you like. But the technology behind it is fairly generic. How is that?
Hugely helpful. I was typing as fast as I can. And Sean, since I kind of, held you up as the example of one of the more explicit talks speaking about how our perspectives need to change. Can you give us a little bit more on that?
Our perspectives. I've spent a lot of time talking with some of the technical guys, and they think we'll follow their instructions, and we kind of don't. But what I do see is that as we build a system, we become more adaptable to it. And I think change is something which is pretty difficult to describe. And I've seen a lot of organizations say, no, we won't do that. That's impossible, our IT department. And then suddenly COVID turns up and we can do what we did before without having some of those things before. And I've seen production facilities like that. And as you come into it, everybody's got their own kingdoms. And I think making some of that much more visible, I think a lot of it comes from transparency. And it's the digital twin is just another tool within the digital toolbox that we've got. We have to move stuff around. We have to bring people around. We have to get people to engage. And I think we're beginning to turn the corner where technology, instead of being kind of clumpy, becomes a little bit more useful and helps us to do things. And it's not kind of felt like the enemy that it was before. And I think our involvement within that system will evolve as the system evolves, and that will adjust how the system then evolves. So there's a symbiosis there. We saw some of that stuff didn't work 20 years ago, but I've got a supercomputer now, it's got a phone. So things change. I want to go back to the healthcare system is quite interesting, because I need to have patients, doctors, rooms available. I need to make sure somebody's paying for it. There's a whole bunch of things in the process that can go completely wrong. And if any one of those fails, the patient doesn't get their medicine or their surgery. So I think we need to spend more time trying to understand what the heck we're trying to achieve than just digitalizing it and getting that thing that I have for training, which kind of sucks at the moment. Thanks, Terry.
Yeah, thank you. And I'm going to let that percolate just a little bit, and I'm going to turn to Bob. And Bob, I had the great chance to listen to one of my colleagues who's at UC Santa Barbara, Matt Bean, give a talk last week. And he's, been able to look at some of the organizational implications and, kind of sticking with the medical point that Sean was making. He has a piece that I think he even was able to write an article for Wired magazine, and they certainly picked up on this research, showing that the greater use of robotics in surgeries was actually causing surgical students to get less time and actually be poorer performers unless other things happen. It was a very complex kind of story around that. And his most recent work is looking at applications of robotics within large warehouses. And one of the things he raised was different managers' skills at figuring out who the humans were who were actually having good ideas about improving the overall system. And you had, I believe, mentioned the digital blue collar workers, if I'm getting this all right. And how can what should we be looking for around that kind of a skill, that person who's going to be able to turn to the vendor? You know, first of all, the vendor has to be smart enough to be listening, and he found some differences in that. But how can that vendor or the manager in that system, you know, how can we help them look for those great ideas coming from those blue collar workers?
I've talked to a number of companies that have smart factories that have been set up with 5G private networks. And one of the things they say is that they're really recruiting a very different workforce than they would in a traditional factory. That the people they're trying to recruit are fairly facile in working with data, with software, with AR or VR. And so it's a new set of skills. And I think that some of the companies are trying to train people in this skill set that they need. And the other thing that I've seen happen within organizations that I was thinking about after the last presentation is, if you look at the pharmaceutical industry, there's been a huge disruption because some organizations really know how to use AI and create new opportunities. So there's a company outside Boston that's actually run by a machine learning expert. I think it's called Bayer, BHR Pharmaceuticals. And the guy who runs the company had a cream that he thought had cancer reducing properties. And he put a few teams together. Within 6 months, this small company that probably did not raise more than, I don't know, 10 or $20 million, had 3 cancer targets. A traditional pharmaceutical company would take, you know, at least a billion, maybe more like 10 billion, and over 10 years to come up with one target drug. And this has caused kind of organizational disruption throughout the industry. There are a lot of companies like Boehringer Ingelheim, where they basically took all of the power away from the IT group and said, you know, you're going to run machines. We have all these other people, and we're going to put together kind of a mixed skill group that has statisticians, mathematicians, data scientists, and others. And we're going to form a number of kind of SEAL teams to go after things like Alzheimer's, come up with, you know, how do we measure when a drug is going to be effective? So they basically started to be very much more innovative than they used to be. And this is really kind of shaking up the industry. I mean, I think one of the reasons we've got the shots for COVID is that the companies that have worked on it have been able to use the knowledge synthesis that I've talked about, at least within their companies. And they've drawn on previous research, like Moderna had done earlier work on some of the related diseases, and was able to take that and use it almost as a pattern.
Yeah,
or
they had a running start. Absolutely.
Yeah, so like, in 30 days, they had a drug target, which is
Yeah.
almost unheard of, you know.
Yeah, thank you. Thank you again. I went on mute so I could do some typing here. And Sean, I see your hand, but I do want to turn to Aaron first. And the spot I'd like to put you on is that you raised the issue of both antagonistic behaviors towards the robotics as well as hacking, which I would say was just a 3-level up version of that. And what can we do about that?
I honestly don't know. I'll put it this way. The robots are successful when the environments are managed and controlled for right now. It's the reason why you are going to see self-driving buses in dedicated lanes far before you see consumer-based self-driving cars. I mean, some of them are on the road, but I had someone in the self-driving car industry ask me, like, what would I do to run a public information campaign, almost a PR stunt, to get other drivers to act nicely to self-driving cars? And the answer is you can't. For robotic safety, the other for people messing with robots, when robots are in warehouses or truck yards, or the good news there is you can train your workers, and the safety systems themselves are evolving. Veo Robotics, VEO, they're using 3D cameras to sense the proximity of a person. So like a collaborative robot actually has little value as a slow collaborative robot that has to be slow to be safe. It has cycle time value, and a collaborative robot can run at speed, but then it's not safe to be in proximity of anymore. So since there are safety sensors that are detecting when a human's nearby to slow the robot down to safe speeds, and then when the human goes away, it can be fast again. So all this to say, when I was working on LiDAR and 3D cameras, having better camera intelligence for what the people are doing around these systems can then tell the fleet manager that the robot should avoid this place or go slower, because the safety concern is very real, and that is one of the concerns that is going to limit the deployment of these systems.
Thank you for that. I'm going to be using that as an example to be sure as I talk about this sort of thinking in 5T approach, right? You know, what is that target? Well, you know, safety is going to be a big piece of all of this. And then what I heard was we can't expect a lot from the talent in the global sense. And so it's going to be on the technology and the technique, at least for the current times. But the idea of the PSA, I'll be pondering on that one to be sure. Thank you. And Sean, do you want to have the last word?
I would just like to follow on from Bob. Mixed teams in production has always been really, really productive with putting lean through or putting other improvements in the factory. And I think we make too much by specializing there. I do want the data scientists there now. I want some other people. And I think then you make better decisions. I even quite like accountants and lawyers. I think they can be quite fun sometimes. Really helpful. Cool, thank you.
More perspectives to panel 2. Thank you all so much.
Thanks.
And I look forward to the opportunity at some fine Isip event, ideally at Hicks, to have a Mai Tai and continue these conversations for a long time to come, no doubt. Jim, I'll pass it back to you.
Great, thank you. Thank you, Terry. Thank you, panel 2. So actually, Ralph, did you want to say a little bit about the white paper, or?
Just quickly, we want to leverage our value proposition here on all of these discovery summits by trying to produce white papers, or in some cases books, in our Business Expert Press series. So I'm going to be leading the effort to generate 2 papers off of this Discovery Summit. One, just a brief summary of the summit that will go up on our website. And then within a month or so, a more elaborate paper about the whole topic of AI and automation.
Great, thank you, Ralph. And yeah, I'll just add, you know, my thank you to the speakers, the moderators, the participants. This ISIP Discovery Summit on AI and automation is almost over. And just as a small thank you to the moderators and panelists, you will get an ISIP Knowledge Sharing Eminence badge that I'll be sending out probably in a week or so. And we do want to remind everybody, I put the link in, ISIP does give an annual Service Excellence Award. Actually, Ralph was the brains behind that, and I think the committee just awarded last year's, but you can start submitting for next year ISIP Service Excellence Awards. And I think one of the things that we heard today was It is a big, big motivator for AI and automation when excellent service comes out. We heard that repeatedly.
Trial version.
Also, ISIP institutional members can request additional discovery summits to you institutional members out there.
Trial version.
If you're not already, if you're not already a member, please join ISIP and consider, if you're leaders in an
trial
organization,
version.
Consider being a sponsor. Well, with that, I think we've come to the end of the Discovery Summit. So you will be getting a copy of the white paper when it's done. We'll mail that out to all the participants. Also, ISIP newsletter people will get it, so don't worry about that. We are checking with the authors about sharing the slides, and this recording will be on the ISIP website. So thanks, everyone, for your time today. That's a wrap.
Thank you so much.
Thank you.
Thanks,
Thank you.
everyone.
Thank you so much. Wonderful.
Bye, everyone.
Bye-bye.
Bye-bye.
Bye-bye. Bye. Thanks, Jim. Bye.
Thank you, Walter. Thank you for hanging in there. I saw Hidaka-san and lots of people from around the world. Thank you, Walter.
Yes, it was a great meeting, to be honest. Particularly knows the second session is I'm very familiar with, in particular the presentation about the manufacturing was very exciting for me. And the talk from Sean about digital twins, that's what we are talking about too very much, how we can get digital twins from for service processes as well, for service products, for example, to describe them better. That helps make me for the communication between companies and providers and customers, for example. That's a very exciting topic, digital twins and services.
Absolutely, absolutely. Yeah, and we'll look forward to finding out more about Fraunhofer robots as well in the future.
Yeah.
I'm sure you're doing some interesting things, and I like how some people described it with the the exoskeleton approach to motivating investment in this AI and automation. So hopefully lots of good things to come. Again, thanks, Walter, for hanging in there. I know it's getting late there.
Take care, Jim, and thank you very much again for the invitation. It was a great pleasure to be here. Thanks a lot. Bye.
Bye for now. Bye for now. Oh, and Monica, I see you're still there. Hey, Monica, thank you. Rick McMaster, thank you, Rick.
Hello, Jim. Hello.
Hey, Simon, how are you? And Monica. Hi.
Thank you. Thank you for the invitation. It was very interesting.
Yeah.
Jim, can we have the recording and the slides?
Yes, you'll get the recording. I still have to ask permission on the sides because a couple of them had confidential on it. So I got to ask those. Maybe they can do a non-confidential version. But yeah, we'll get most of the slides. The speakers have said, yeah, no problem. There's a couple I got to double check. And the recording will go up on the ISIP YouTube and then the ISIP website. So
good,
yep.
Good. Thank you.
Yeah,
so it was a very interesting workshop.
Absolutely. Yeah, there'll be more coming as well. Bye for now.
Bye.
Have a good evening.
Bye.
Have a good evening. Bye.